First, I want to say welcome to the course. We're going to be spending a fair bit of time together going through a number of topics. I really appreciate that you chose this course to learn more about security testing and penetration testing and all of the tools and techniques that are around, particularly using open source software. So you don't have to spend a lot of money on commercial software just to get started. You can really learn the concepts very well for free using open source software. And we're going to be spending a fair bit of time using that. Getting started, what do you need? Well, certainly you need an interest in doing some of this work. You probably need a bit of knowledge about operating systems and how they function so that you can get around. We're going to be using a couple of different operating systems. You should probably know a bit about networks because ultimately we're going to be communicating over networks. And ideally, you should have the ability to run virtual machines. It will make your life a lot easier if you can get a copy of VMware, Parallels, VirtualBox, something along those lines so that you can install operating systems so that you've got both attack systems and you've got target systems to work with. So the operating systems that we're going to be using Kali Linux, we'll be using Windows, and then for targets, I've got a copy of Metasploitable, which is available for free if you just go do a search for Metasploitable. You'll see a couple of different versions. I'm using version 2. You can use either version 2 or 3, it doesn't really much matter. And I'm using Windows as well. So the topics that we're going to cover, we're going to talk about what security testing is and the types of things that you need to know in order to get started doing security testing. We're going to talk about reconnaissance and the various techniques that you can use to recon your targets. We're going to talk about scanning, both network scanning, and we're going to be talking about vulnerability scanning as well. We'll also spend a lot of time talking about how to exploit vulnerabilities. We'll be using Metasploit for that. And we'll also talk some about various client-side attacks. So if you're ready to get started, before we go, you probably want to obtain a copy of Kali Linux. Most of what I'll be doing over the next several dozen videos is going to be inside Kali Linux. We're going to be working with Windows a little bit, but frankly, it's just a lot easier to use Kali because everything that we're going to be doing is already there. You don't have to go get additional software and install it and go through all of that hassle. Everything that we're going to be working with is already right inside Kali. And so it makes life a lot easier. Learning Linux, if you don't know it, is also a really important skill to have if you're going to be doing any sort of security testing because so many tools really only work inside of Linux. You really should get a really good handle on Linux, and Kali's a good place to get started if you don't have that skill. If you're ready to go, we can move on and just get started. Before we get started working on actually engaging in testing activities, I'm going to go through some foundational things around how we're going to get a lab set up and all of the surround stuff that you're going to need in order to be able to do the exercises that we're going to be working on. So the very first thing I want to talk about is an operating system that you're going to see me use an awful lot, and that's Kali Linux. Now, this is an operating system, a Linux distribution actually, that was developed specifically for security testing and other security functions. There are a number of tools that are built into it that are associated not only with penetration testing, but also other activities as well, including, for example, doing forensics work. This is a Linux distribution that's based on Ubuntu Linux. If you've got any familiarity with Linux at all, you may be familiar with, say, Linux Mint or Ubuntu Linux, and this is going to look an awful lot like that. I'm going to show you a set of tools that come with Kali Linux and explain why I'm going to be using Kali a lot. We'll also be using Windows. There are some tools that are available on Windows, and I recognize that most people are going to be using Windows on a regular basis. So we are going to be using Windows a lot, but one of the reasons I like Kali is because everything is contained within it already, and I don't have to do any extra work of setting things up because most of what I need is going to be just installed by default. We're going to take a look at the various tools that are installed by default on Kali Linux. You can see there are a number of tools that are available for information gathering, and you can see the different categories that they have broken the tools listings down into. We've got vulnerability analysis, web applications, wireless attacks, and then exploitation tools that we're going to be working with a little bit. As I mentioned earlier, you can do forensic analysis with Kali Linux, and here are some forensics tools that just come with Kali Linux. Reverse engineering, maintaining access, password attacks, we're going to be doing some of that as well. So you can see that just using Kali already brings a lot to the table. And even if you're not familiar with Linux, it's not necessarily that difficult to get up and running with a lot of the tools that Kali has. Part of the reason for that is that there is a menu that is broken down into the different categories, and all you need to do is just select something here, and it's going to pop open a window. In some cases, it's going to be a terminal, but it's going to launch the application for you that's probably going to give you help output, as in the case here with SQLmap. Kali Linux is a great resource, and we're going to be using a lot of it, so I wanted to spend a little time introducing Kali and what it brings to the table for us. It's probably impractical to think that you're going to have a system for everything that we're going to be doing here. So what I find is making use of virtual machines is really beneficial. A virtual machine is where you are running an operating system within another operating system. In terms of virtualization software, you may be familiar with something like VMware, for example. You could buy a copy of VMware. So, for example, there's Workstation for Windows, there's Workstation for Linux, and then there's Fusion for Mac. I happen to use Parallels a lot, and that is one that runs on Mac OS. So there's Parallels here that you can get a copy of for your Mac OS system. Or if you want to just go and use something that's not going to cost you anything, and it actually generally works very well, you could take a look at VirtualBox. VirtualBox is free and it does the same thing that VMware and Parallels does. And it also runs on multiple operating systems. So it will run on Windows, Linux, Mac, and Solaris hosts. And of course, it supports a large number of guest operating systems. The guest operating system is actually the operating system that is running inside the virtualization software. So, for example, I've got Kali Linux running here. This is not a standalone Kali Linux system. This is actually the operating system running inside virtual machine software inside Mac OS. I've got my virtualization software that is actually taking care of pretending to be the machine so that the operating system can interface with the virtualization software. And as a user, I really have no awareness that there's anything different. It behaves exactly as it would if it were running on a standalone machine, other than it's a window on my desktop rather than just a standalone monitor with a computer sitting next to it. Virtualization software is going to help you be able to run multiple operating systems simultaneously without having to spend the money on individual systems for everything that you may want to be doing at the same time. For example, later on, we will certainly be running at least Kali and one other operating system at the same time. If you weren't using virtual machine software, you would have to have two separate systems. In my case here, I'm going to be doing everything all on one computer system, and I'm going to have a couple of different virtual machines running with operating systems running inside of them. As I mentioned, we've got Kali Linux, and we've also got Windows systems that we're going to be using for attacking. But you probably want systems that are really designed to be attacked. we're going to look at a couple of vulnerable operating systems that you can play around with, because if you're just using a standard Windows 10 operating system that's probably kept reasonably up to date, then you're going to have a really hard time getting very far. In order to see some success and be able to understand what this type of testing looks like, you really want something that's going to be vulnerable to attack so that you can really get your hands dirty and really understand what it feels like, what it looks like to be doing this, rather than just, I don't know whether what I did failed or whether the operating system just isn't cooperating or whatever. You want something that you know the vulnerability is there. And so when you run it, if you're not successful, you know it may have something to do with how you did it rather than the operating system itself just simply not being vulnerable. We start with vulnerable operating systems, so at least you know as you are getting started what you should expect to see as you're getting going. Here's one. It's Metasploitable. Metasploitable 2 is a Linux distribution or a Linux version that is designed specifically for exploitation with Metasploit. I'm at the Rapid7 community webpage, and Rapid7 is a company that makes not only Metasploit, they actually sell commercial versions of Metasploit, but they also have a vulnerability assessment tool called Nexpose. We will take a look at that a little bit later on. And just for something to play around with, they also maintain Metasploitable. As I said, this is a version of Linux that can be exploited with Metasploit. So you can download a virtual machine image that you can run inside your virtualization software. So if you click on this link here, it will take you to a page where you can download Metasploitable. It is going to ask you for information so that they've got something to give their marketing people, and then in compensation for that, you get a copy of Metasploitable. That's not the only vulnerable operating system. If we were to go to VulnHub, for example, you would be able to find a number of operating system images that can be used for a number of different purposes, actually. So some of these are designed for capture the flag use. There may be a specific activity that you are expected to get to. So these are created for capture the flag activities or competitions. There are a number of other ones that are available here as well. You can see that there are several pages of potentially vulnerable operating systems, and you can go skimming through these and try them out if you want. These are just downloads that you can actually make use of and then play around with. We're going to be using Metasploitable because, as I said, it's one that's really geared towards being exploited with Metasploit, and all of the tools that you need to exploit Metasploitable are on Kali Linux, not surprisingly, perhaps. There are a number of places that you can go to get some of these operating systems. As I said, VulnHub here is one that's got a large collection of them. And then, of course, as I said, we're going to be using Metasploitable. We've talked about using Linux, and if you're not familiar with Linux, you don't have to fear quite so much. We're going to be using Windows, and a lot of the tools that we're going to be using on Kali Linux are also available for Windows as well. I've got Windows 10 here. If you're running Windows 7 or Windows 8, that's generally going to be fine for the types of things that we're going to be using under Windows. So, for example, we could run Metasploit on a Windows system. You can install Metasploit. We will be using Metasploit a little bit on Windows. Nmap is another one. Nmap is a port scanner, and you can install Nmap for Windows and use it there as well. There is Nexpose, which is available for Windows. We're going to be using a little bit of that as a vulnerability scanner. So there are a number of tools and utilities. The one thing that we don't get quite as much of is we don't have quite the number of command line tools that are just installed by default for doing a number of things. For example, Whois and Dig. where we're doing a little bit of reconnaissance. There are ways that you can get those tools on a Windows system. They just don't come installed by default as they do on Kali Linux, which again is one of the reasons why you'll see me using Kali Linux quite a bit, is because a lot of the things that I just use on a very regular basis, day to day almost, are installed by default on Linux systems. Again, we are going to be using Kali a lot, but don't worry too much if you're more familiar with Windows. There are ways to do a lot of the things that we're going to be doing under Linux, under Windows as well. So we are going to be using Windows systems. Again, I've got a Windows 10 system here, but if you've got Windows 8 or Windows 7, that's going to do just as well in most cases. Methodologies are really important things. They provide a framework that you can work inside of so that you've got a high level understanding of what you're trying to accomplish and how you're going to go about accomplishing it. So, when it comes to penetration testing, there are a number of methodologies that you can use. I'm at owasp.org here. This is a page that just has a list of some of the penetration testing methodologies that you could look at were you interested in seeing the various methodologies that were out there. The penetration testing execution standard is a 7-phase methodology that involves pre-engagement interactions, intelligence gathering, threat modeling, vulnerability analysis, exploitation, post-exploitation, and reporting. There's also the PCI penetration testing guide that comes out of the data security standard. So there are components associated with doing PCI-based testing because penetration testing is one of the requirements from the data security standard from the payment card industry. Now you can see a different penetration testing framework here that's much more involved. And this may have a number of categories that are just not relevant to some of the testing that you're going to be doing. So, for example, AS400, not everybody is going to have a mainframe or a mini computer. So, you may not be doing things like AS400. They may not have Citrix, for example. So that's another category that may just not apply at all. And that's one of the things about a methodology as opposed to a process or a procedure. Methodology, as I mentioned earlier, is really high level guidance. And it doesn't necessarily mean it's a set of steps that you're going to follow every time that you do something. It's really just a set of here's some categories that we're going to be doing some activities in, maybe depending on the particular engagement. So, again, there are a number of penetration testing frameworks that are available, and you can certainly look at the various methodologies that are available. You can compare them, see what one is going to work best for you. For our purposes, we're just going to use a very simple, streamlined methodology where we're going to start with reconnaissance and we're going to move to scanning and then vulnerability scanning. Then we're going to move to exploiting vulnerabilities. We'll look at client-side attacks, and then at some point we'll talk a little bit about reporting as well. Since that's less of something that I can show you hands-on, we're not going to spend a lot of time, but there are certainly places that you can look at sample reports and report structures that may be things that you can use as you're doing reporting. Certainly, reporting is a very important component of penetration testing because you need to have a set of artifacts that you can present back to either your employer or the customer in the case that you're doing contract work. You need to have a report at the end, and ideally the report is going to not only include your findings, but also what they can do about remediating those findings or fixing the holes that you have identified. One really important area that we need to talk about is the idea of ethics and a get out of jail free card, so to speak. So, within the field of information security, there are a number of different organizations that will talk about ethics and their code of ethics. So, ISC squared is one of them. Ethics is a really important concept within information security. you are going to be the type of person who's going to be trusted with access to a lot of really sensitive information. And so you need to have the very highest level of ethics and work procedures so that you can continue to be trusted with the information and the access that you have been provided either by your employer or by the company that is contracting you to come in. ISC Squared, for example, is the organization that is responsible for maintaining the CISSP certification. And so they have a code of ethics, and it says here the safety and welfare of society and the common good, duty to our principles and to each other requires that we adhere and be seen to adhere to the highest ethical standards of behavior. What they say is you must protect society, the common good, necessary public trust and confidence in the infrastructure, act honorably, honestly, justly, responsibly, and legally, provide diligent and competent service to principals, advance and protect the profession. Now, ISC Squared isn't the only organization that talks about ethics. The Certified Ethical Hacker from Msfconsole also has a code of ethics. You might guess that Certified Ethical Hacker ethics is going to be an important component. This is the code of ethics that Msfconsole says is important for you to follow. So they talk about privacy, protecting intellectual property, and making sure that you are disclosing what you need to disclose, providing service. Here's one that's really important. Never knowingly use software or process that is obtained or retained either illegally or unethically. You're going to be shown a number of really powerful tools that are going to give you the potential to get access to systems. It's important, and I can't stress this enough, it is important that you only work on systems that either you own or you have explicit permission from the system owner to work on. The reason I stress this is because this is the type of area where not only is it an ethical consideration as a professional, but it's also a legal consideration. If you start poking and prodding on systems that don't belong to you, what could end up happening is you could end up doing something that is illegal. You end up in jail. Obviously, not a very good outcome for you. So, make sure that you are working on systems that either you own or that you have explicit and ideally written permission from the system owner. And that's where I talk about the get out of jail free card. You get that piece of paper that says, here is what we are asking you to do. Here is the entire scope of the engagement so that you have that written permission for what they are contracting you to do or what you are being employed to do. And that piece of paper, that signed piece of paper, is your get out of jail free card. If something happens, you get to say that this is what I was told to do. It falls within the scope of the engagement, and the system owner has given me permission to do that. Ethics is really important, and it's something to always keep in the back of your mind as you are working through some of the exercises and the various tools that we're going to be working on going forward. I want to start going over just some very basic tools that you're probably going to be using on a pretty regular basis. One of them is actually Telnet. You may be familiar with the Telnet server, and everybody says, oh my gosh, don't use Telnet, bad, evil, not good. Primarily because Telnet, the server, or Telnet, the protocol, is really based around plain text transmission. If you are communicating with a server and it's in plain text, that means usernames, passwords, all sorts of data is being transmitted. However, we can actually use Telnet, the client, because Telnet on the client side is really just a program that initiates a TCP connection to a remote system. What we could do, for example, would be to connect to, in this case, Microsoft's web server on port 80 using Telnet. Now that's going to initiate a TCP connection, and what we can then do is interact directly with the protocol that's there. In our case, we're going to be using HTTP. because this is a web server after all. And then once I have finished with my communication, my version of the protocol here, or what I'm sending using the protocol, then I can get the response back. So we can do this with pretty much any protocol that you would like. For example, I could say go to smtp.google.com, and that's going to be on port 25. So you can see I'm using Telnet and then the host name and then the port. And as long as I specify the port, what Telnet is going to do is it's going to initiate a TCP connection to that port. If I don't specify the port, it's going to assume port 23, which is the Telnet port. I don't want to do that because A, I don't want to be bugging other systems, certainly. Refer back to our ethics conversation. But also, there's really no Telnet server that's going to be listening at smtp.google.com. So there's really no point in me doing that. So what I've done here is I have sent a message to this particular server at google.com, which is their mail server, and I get a response here saying, I talk extended SMTP, and this is mx.google.com. So I could actually initiate a command here. This is using ESMTP. So I've just said hello to the mail server, and then I could continue and create a mail message in this way. I can use Telnet to communicate with basically any host that is running a plain text protocol because Telnet itself doesn't do SSL TLS. There are other ways of doing that. But if you've got something that can do plain text and it's running TCP, you can use the Telnet client to communicate with it. And that's a good way of just doing a quick sanity check sometimes to see whether the port is responding and what the messages that you're getting back look like. Now, this time we're going to be using a program called Netcat. Netcat behaves very similarly in some ways to the Telnet client. What I can do here, just as I did with Telnet, was I can connect to the web server for Microsoft here, and I don't get the same you are connected messages as I did when I was using Telnet, but I can just continue here, feeling comfortable that I am connected because Netcat didn't hang or wait or anything. It just issued me a way to start typing. You can see that I was connected. I got a message back. Now I can also use Netcat as I did earlier with Google. I can connect to the mail server, and you can see that this says ESMTP server ready. So I can say, just issue a hello, and it tells me it's pleased to meet me. Great. One of the differences, though, with Netcat and Telnet client is that with Netcat, I can actually specify that I am going to be listening. If I were to say -L, that's going to say listen, and I could just say listen on port 1200. So now I've got a listener on port 1200. Well, this is TCP. I can use Netcat to communicate using UDP, which is something I can't do with the Telnet client. Telnet client doesn't support UDP communication. All I have to do is say -U, and then let's just say we're going to go to 172.30.2.42.1, and we'll try 53. So I am communicating with port 53 on the router that's on my local network. Using Netcat, I can communicate using UDP, and I can also set up listeners with Netcat, which is really helpful. Netcat is another great little utility that you may want to make use of, and it's a good tool to have in your little bag of tricks. This time we're going to look at a very simple utility, and it's one that you may have used before, but what I'm going to do is I'm going to show you some different techniques for how to use ping. Normally, you might just say ping 172.30.42.1. Ping is a utility that also works on Windows just as it does here on Kali Linux. One of the differences, though, is Windows will have slightly different parameters than the ones we're going to be using here. It still does the same thing, it just may use different flags in order to do them. So I can say ping 172.30.42.1. Ping under Linux will just keep going until I kill it, unlike under Windows where it just sends 4 and then it's done. Here I can say -C4, it's going to send 4, and then it should complete at that point. That's how you would do one that looked just like a Windows system. I can specify a count. I can also do something like pinging the broadcast address. Normally, if I were to ping the broadcast address, and if you are less familiar with TCP/IP, every network block comes with a network address, which is the lowest address of the block. In my case, that would be .0, and a broadcast address, which is the highest address in the block, meaning I am sending a message to everybody on the network. If I send a message to .255 here, so this is my broadcast address. If I were to ping this here, it should say exactly what it says. Do you want to ping broadcast? Then -B. So I can say -B, and then I'm telling ping I do actually want to send a broadcast. And now you can see that I'm getting duplicate messages because I'm sending the broadcast ping out and I'm getting responses from multiple systems on the network, just as I would expect to. Now, something else that I can do using ping is I can say pattern. So that's -P. And this has to be in hexadecimal because we're talking about byte values here. And I can just say 172.30.42.1. That's just going to send the message out. No big deal. What I can do in addition to this, though, is I could say, I actually want my packet to be 800 bytes and not the typical 56 bytes. Now I'm sending 808 bytes, and we're getting roughly the same round trip times as we were before, mostly because 800 really isn't a very large value and it's still on my local network. But if you wanted to do some stress testing a little bit, you can use ping to send really large packets out onto the network. And you could also mark them using the pattern here so that there was a very specific marker for you to be looking at on the other end. So that's one reason why you may want to use the pattern. And also, as I said, you may want to do load testing where you're using much larger values. Here, for example, we're seeing 4 milliseconds where before we were seeing just a single millisecond because I increased the packet size by a factor of 10 to 8008 bytes from just the 808 bytes that we were using before. Ping is a really useful utility, but it's useful for more than just, can I see whether a host is up? I can do a little bit of load testing. I can mark packets as I send them through the network, so there's a pattern that I can particularly look at. I can also specify exactly the number of packets that I'm going to be sending, and of course, I can also ping the broadcast address using my ping utility here. As we work through various settings and scenarios here, what we may have an opportunity to do is use some browser extensions. There are a few browser extensions that we're going to talk about. I'm using Firefox. Some of these will also work inside of Chrome, some of them won't. And the reason for that is because Chrome is better locked down than Firefox is. So Firefox will actually allow us to do some pretty bad things within the browser framework that Chrome doesn't allow us to do. I'm going to go to add-ons here, and I'm going to go to extensions. Because Chrome doesn't allow me to do various things with their plugins or extensions, I use Firefox for some of the testing that I do. One thing that I want to look up here is an extension called Tamper Data. Now, tamper data is something that allows us to do web testing by capturing messages that are going back and forth between the server. So that's an extension that can be useful to take a look at. We're also going to take a look at an extension called Passive Recon. Passive Recon is something that allows us to do some recon or investigation of our target without actually doing any direct interaction with the target itself. This is a really useful utility. And we've got another one again for different types of web testing. We may use something called ground speed. So there are a number of plugins that you can look for. These are some that I use on a semi-regular basis. You may find there are others that work well for you. So this one is called Hackbar. It's really just a way of getting some quick access to tools like decoding and encoding, as well as some functions that are maybe a little bit more obscure in XSS, things that you don't necessarily carry in the top of your head. You notice the note here, I tend to use it as a notepad. It's got that capability as well. So there are a lot of tools that are just built straight into Hackbar. And when you install it, it just becomes another toolbar that is embedded within Firefox. So there are, again, a number of browser extensions or add-ons or plugins that you may find are really helpful to you as you are doing different types of testing. As I said, these are a handful that I use on a semi-regular basis. In addition to various web browser plugins, there are a number of websites that may be really useful to you. One of them is an IP calculator. This happens to be one right here. You can just do a Google search on IP calculator. If you need to know what the network block or the number of hosts within the network or any number of details related to IP addresses and networks, you can go to this site here. You'll get the net mask from the CIDR notation, which is the number of bits that are in the network mask. You'll get the network address, the broadcast address, the minimum host, the maximum host, and then the host per network. IP address calculator is really useful, keeps you from having to do binary or hexadecimal in your head, for example. Another one is Geek Tools. Geek Tools will provide the opportunity to do a trace route or at least link to trace route sites. And you can also do a Whois from the Geek Tools Whois page. So, for example, I could plug in an SZPFL, which is the CAPTCHA code there. And then if I were to say, just do a Whois on an IP address, I'm going to get all of the results back. We're going to take a little bit more detailed look at Whois a little bit later on, but this is a website that is useful as well. You also might want to do GeoIP lookups. In other words, you may want to look up addresses from IP addresses. You can use geoiptool.com. That's one site that will do GeoIP lookups. There are frankly a large number of websites and web pages that are available. Another one that I want to take a look at here is the exploit database. So the exploit database will give us access to the current exploits that are available, including remote exploits and web application exploits, local and privilege escalation exploits. It also hosts the Google Hacking Database, which is using keywords to do very specific lookups. And so you would use some of the Google keywords, like, for example, site and then in URL, to get to very, very specific information. So here, for example, is a Google search, sometimes called Google Dorks, and you can see the reference to dorks right there. And if we were to look that up, it would be WebEx sites that included TC3000 within the URL. There's not really a description here in terms of what this actually does, but it does give you a very brief example of what a Google hack would be or a Google dork. There are a number of websites that you can use to very quickly look up information. And if you don't have access to command line tools for some of the things that we can do on command line, you can use sites like Geek Tools, for example, to do a Whois lookup. Or there are a number of other web pages that will do things like trace routes and so forth. As you are testing, you're going to be generating a fair amount of data depending on what you're testing. So, if you're testing even a small network, you may be acquiring a lot of information about IP addresses and hosts and applications that are running on those hosts. And having something to keep track of all of that information is really useful. Certainly, you could just use a text file. So, you could use text editor, any type of text editor that you wanted to. You could use a spreadsheet if you wanted to do that. Kali Linux actually comes with a really good way of keeping track of information. So we're going to look at Maltego Casefile. Now, Casefile is a way of gathering information and putting it into context. Let's just create one here. Let's just say I've got a desktop computer. So I can take that, I can drag it out onto my graph. And then what I can do is if I double click it, I can add a number of notes. I could add attachments and notes. I could also create properties here. So the device, maybe we gave it an IP address, for example, however it was you wanted to do that. I can also change the type once I've got something out there. I can change the device. I can also create events and groups and infrastructure. And you'll see over here, we've got this as well. So I might have a company, for example, or I might have infrastructure. I could have an autonomous system, and I might include that within my information. So AS number here is 188, which happens to be whatever this defaults to. Notice that if I pop that open, it has a link to Google Me or Wikipedia Me. So you can very quickly get access to information outside of Casefile. And we can add people and we can add social networks. So you can see that there are a number of ways that you can organize information and store it all within Casefile. And that gives you a really rich and detailed way of viewing the test that you're doing. So you've kind of got everything visually all in one place, and you're not necessarily searching through text files in order to find the specific information you're looking for. Maybe you're just looking for a specific entity that's on the page here. So, for example, I could say this is web server A, and then we can just store that. Now we've got web server A. I did something to web server A. I go to the notes field, and now I've got a detailed list of everything that I did to web server A. So you can keep track of tasks within here as well. So Maltego Casefile again comes with Kali Linux. It's installed by default. You can use anything that you want that makes sense to you in the way that you organize information. But Maltego Casefile, as I said, is a really rich and detailed way of storing a lot of information that you can certainly use towards how you're handling your security testing. So we're going to talk about Google hacking. Google hacking is not the sort of thing where we're trying to break into Google. Instead, what we are doing is we are trying to get better results out of our searches. Google hacking is a way of using specific keywords in order to narrow our searches down. So, for example, we can say site and then Microsoft.com. The site tells us that we're only going to use results that fall within the site Microsoft.com. So I can also say, for example, file type, and I could say XLS. File type XLS says we're only looking for spreadsheets. Right now, we are looking for spreadsheets that are falling within the website Microsoft.com, and then I can do something like Windows 10. I can say we're only looking for results that reference Windows 10 and have a file type of XLS and are within the website Microsoft.com. So you can see we've got only results that are from Microsoft.com, and these are all Excel spreadsheets. Now, there are a number of other keywords that we can use. For example, we could say in URL, and we're looking for something that only exists in the URL, which is the address in the address bar. We could say in text, for example. if I were to say in text, I'm looking for a result where what I'm looking for is only in the text and doesn't exist in, for example, the title. And speaking of that, I could say in title. We've got a number of different ways that we can really narrow our searches down by using these Google keywords. And it's really easy to get all of the list of keywords just by looking up Google hacking keywords list. So we've got a complete list of the Google hacks, and these are all of the keywords that may be available. So you could say include or exclude, and this mentions that you could use Boolean terms like and or, but there are other places that will give you lists as well. So we've looked at some of the keywords that you can use in order to do Google hacking, which again is really about narrowing the search results that you get back down to as really narrow a field as we can. There is actually a Google hacking database, and this is a website that keeps track of really useful search terms in order to locate things that may be of specific interest. And so right here on the very top, here is a list of some that have been turned up recently. And what we've got right here is in URL forgot.do semicolon J session ID equals. This looks like it's going to be a forgotten password portal. If we were to click on this, it would fire up Google for us and actually perform that search. You can see that there are some of the results. We're going to go back here to the Google hacking database. Now, this is a list at the top of ones that have been turned up recently, but down at the bottom, we've got a list of categories. We've got files containing passwords, for example. And right here is in URL pro FTPDP ASSWD. So it looks like there may be pro FTPD passwords available using this particular Google dork. Right here, we've got WordPress passwords, so in URL wp-config, and we're not looking for in-text wp-config. We're looking for db password, however. That's another one. So we've got files containing passwords, we've got sensitive online shopping info, we've got network or vulnerability data, so there may be things like log information. Looks like here's some monitoring graphs. We've got Cacti system and some SNMP graphs. Cacti is a monitoring application. You can see that there are a large number of search terms that people have turned up that will give you information about a wide variety of things. And you may be able to turn up information about your target right here. So there are things for webcams, for example, and various other vulnerable services. So you may be able to really isolate specific systems on your target network using the Google hacking database and some of the different search terms and search strings that are available here. Now, we took a very quick look at using Whois through a web interface before. What I want to show you now is using Whois from the command line. And no matter where you are running Whois from, whether it's a small application on a Windows box or whether it's through a web interface, what you're doing is you are communicating with the various regional internet registries. And Whois is going to work the same no matter what mechanism you are using to interrogate those databases. So, for example, I can look up an IP address, and what I am going to get back here is I'm going to get back the name of the company that owns this particular IP address. Keeping along with that, I can do a lookup on a domain name, and theoretically, I can find the name of the company that owns the domain name. Now, some domains are actually going to be private, meaning that they are stored behind some anonymous entity. So you may not always be able to get the information that you're looking for. But in this case, we've got level 3 communications. Now, the one thing that we didn't look at before when it came to the IP address is I looked up one IP address. What I ended up getting was the entire net range and then the CIDR notation, which is classless internet domain routing. And we've got the net handle, and this was a direct allocation. So I can look up other IP addresses, and I can get not only the organization that owns the IP address, but I can get the entire block that the IP address came out of. I've got a way of looking up a lot of information from the regional internet registries using Whois. As I said, I'm using command line here, but in the case of using a web interface, you're going to get the same information back. It's probably going to look much the same as what we are looking at here. So if I were to use the command line, though, one thing that I can do is I can specify which regional internet registry I want to communicate with. So I'm going to query whois.aaron.net here, and I'm going to ask about that IP address. Because it's owned by Aaron, then I'm going to get the information that I need. If I were to check, for example, RIPE, then I'm probably going to get an error back because the IP address isn't actually owned by RIPE, which is the European registry. So you can see that they have no information related to that particular block because it's actually coming out of the Aaron registry, and that was where we looked before. Using Whois, we can gather a lot of information about IP addresses and domain names and host names and so forth. Now, we used Whois to gather information from the regional internet registries. Another place that we can look for information is using the domain name system. Again, if I've got an IP address or if I've got a host name, I can look up information using DNS. So, for example, I can use dig to look up information. So, what I'm looking for is information about Microsoft's web server, just as an example. Now, what dig tells me is it provides me a lot of really detailed information about the query that I actually made, as well as the answer, and then I've got the query time in the server that we used. In this case, what I'm looking for is an A record, which is an address. So I have given it a host name, and what I'm looking for is the IP address back. What I've got is a C name back, which is a canonical name. And then what I'm getting back is another canonical name. And finally, we look up the canonical name that we've got, and we've got an IP address. The canonical name is just really an alias. So if you see CNAME, it's just another host name that is an alias for the host name that you provided. Eventually, you'll get your IP address back. So I can also do a dig on an IP address. Ideally, I should be able to get a host name back from it. Not all IP addresses are configured within the DNS servers of the company that owns the IP address. So this would be a PTR record or a pointer record pointing back from the address to the host name. In this case, we don't actually happen to have one. Now I can look up other types of records. So I could say digmx Microsoft.com, and that is going to give me the mail server. In some cases, you may actually get a number of them back, and they would be ordered in preference, with the lowest number being the most preferential. And typically, you might see 10, 20, 30, 40, 50, and so on. And again, the lowest number is going to have the most preference. So using dig, we can look up different types of records. And dig is usually pretty good about figuring out what it is you are looking for. Now, I could actually say something like this. I could say dig at, and then what that tells dig is I want to change the server. So rather than 75.75.75.75, as we did up here, I am actually using server 4.2.2.1, which is a DNS server I happen to know about. It's up, it's around the world available. So that's a DNS server I know that I can always get to. I'm checking that one and pulling the information, and I'm getting that back as well. So if I want to check against a different server, I can say dig at, and then either the IP address or the host name of the DNS server that I want to use. There are a couple of other tools that we can use when it comes to looking up DNS information. So one of them very quickly is host. And I can just say host Microsoft.com. And what I get back is the IP address. And I also get back the IPv6 address. So I can just use host, and that is going to do very quick lookups for me if all I'm looking for is the either A record or the PTR record. Another utility that I could use is I could say Nslookup, and I'm going to get the same thing back, except that I can also do more complex lookups using Nslookup. If I just type Nslookup, I really get into an interactive mode with Nslookup. Now I could say Microsoft.com, but I can also set my query type to be MX. And now I can say Microsoft.com. And I've got my mail exchanger. I can also set my query type to be the start of authority record. And then I can say Microsoft.com again, and I've got the start of authority record back from the domain. What this tells me is this has a serial number of this, and my refresh is that value, retry is 600, and the expire is there. That's all of the information out of the start of authority record. I can just keep doing that, and you'll notice that every time it looks it up, it tells me the server. So what I can also do here using Nslookup is I can say Microsoft.com and then 4.2.2.1. And now we're using the server here, and we're getting non-authoritative answers with different IP addresses. So there's some sort of round robin DNS going on here where every time you look up the address for that particular host, because Microsoft.com is not only a domain name, it's also a host name. Microsoft.com points to a specific host. In this case, it actually points to 5 different hosts. So you can use host and Nslookup in order to get DNS information, just as you can use dig to get DNS information from the different DNS servers that are available. Now, there are going to be cases where you don't have access to the command line to be able to do some of the things that we were doing, and you may need to be able to use web tools. So we can do DNS lookups from a number of websites. One of them here is the MX Toolbox, and we could do things like just looking up O'Reilly.com. I've got O'Reilly.com. It's doing an A lookup for me, and we can do just simple lookups here. I could do a blacklist check. I could do a DNS lookup. What we were doing was really just a DNS lookup, looking up the A record. But you can see if I did a pull down here, I can do additional lookups for things like SRV records and so forth. There are a number of other websites. So we can go to DNS tools. This is webdnstools.com. Again, I can just do O'Reilly.com here. I can pull down different record types. So we could do an NS lookup on O'Reilly.com, and we're going to get the name servers back that were related to that particular domain. So that's another web tool that you can use. So another one here that I kind of like, and this is at toolbox.googleapps.com. This is the toolbox that Google provides. So here I can do O'Reilly.com. We're going to do an A record lookup. So you'll notice it actually did the A record lookup pretty quickly. Now I can switch over and just click any of these other buttons, and it does the record lookup for all of these types here as well. So I could do a PTR lookup. I can do the start of authority record lookup. I can look for text records. I can also add in a name server here. So I could do 4.2.2.1 and say that's the name server that I want to look at, and it will do the lookup there for me. And you can see that we've got text records. So we've got the sender policy framework record here, the SPF framework. There are a couple of others as well. These are just text records that are needed for different applications. We can do a name server lookup. We can do an MX lookup. And this is really easy to use. Those are just 3 ways that you can do DNS lookups using web interfaces. Certainly, there are a lot of other ones as well. Like I said, I do kind of like this one right here, just because they make it really easy to get very quick access, and you're not cluttered with the more complex interfaces of some of the other web tools that are out there. This is just a very clean interface, very easy to use. But there are certainly a number of others out there as well that you can do DNS lookups through a web interface, which allows you to do them from mobile devices as well, where you wouldn't necessarily have access to a command line or some other tools that would allow you to do these DNS lookups. Now we're going to take a look at Passive Recon here. So Passive Recon is a plugin that works on Firefox. So it's an add-on that you can add into Firefox. And I'm going to go to google.com here, and we're just going to do a quick lookup and just look up DNS lookup. What I've got here is a list of links. And if I set my cursor on top of that and just right click, we can do Passive Recon. The problem with using Google here is that all of the links, and if I just set the cursor over it, and if you look at the very bottom, if you can see it, the link is actually to Google, and then it does a redirect to the actual site. What I'm going to do instead here is I'm going to go to a real website, and we're going to take a look at some links where we can actually do some passive recon and not actually have to go through Google. So what I can do here is if I can just find a link that works, now what I can do is passive recon, and I've got DNS here, and I'm just going to select the top one into DNS. And what it does is it pops open another web page for me. So we do a complete DNS lookup with the SOA record and then the NS record and so forth. Ideally, the idea behind passive recon is you're not actually interfacing with the website itself, but that does require you to have links on another site so you're not actually there. But you can certainly go to the web interface for whatever your target is, and it's just going to look like web traffic. So it's still a little bit passive because you're not probing them directly. Something else you can do is you can do just some canned Google searches. We can look for Excel searches based on this particular domain. We can look up IP information from Central Ops. And so we're going to get the Whois record information and a number of other records that relate to this particular domain name and IP address. And in this case, we're doing a trace route to Microsoft.com. They're doing some service scans here as well. So you can see that using passive recon, we've got access to a number of tools very, very quickly. And I could also use Netcraft here, which is another really useful tool to get the history of the different types of servers that are being used for this particular website. Passive Recon, again, is a plugin that works with Firefox, and you can use it to get very quick access to a number of recon sites so you can get information about your target. Another way of doing reconnaissance in a passive way is to use something called P0F. This is a way of doing passive fingerprinting, and I'm just going to run this. And then I need to generate some traffic. So I'm going to go do a little bit of web browsing here. So we're going to connect to some web servers. Let's go to O'Reilly.com, for example. And then we could go to Kali.org. Then we could go to Microsoft.com. So we've got a number of pages here, and apparently Firefox doesn't like this particular connection, but we still should have gathered some traffic from there. So now I'm just going to kill this, and I'm going to scroll back up and see what we have turned up from the sites that we have gone to. Now, this really does look a little bit arcane, but when you look at it, you can see that what P0F does is it pulls apart the packets it is capturing and it prints out what we have captured in a way that makes more sense. So, for example, what we've got here is a connection from my local system here, which is this one, and the port number is 58994. That's an ephemeral port, and we're going to 72.167.18.239 on port 80. This is an Ethernet connection, and then the maximum transmission unit, the raw MTU, is 1500 bytes. We were able to get that. Now, that's on my local network here, so there's nothing particularly fancy about that. It's Ethernet. We expect it's going to be 1500. If we continue scrolling up here, though, we should be able to turn up some information about the different servers that we were communicating with. As an example, it looks like 72.167.18.239 is running Linux. So based on what P0F was able to determine from the way the packet looked and the signature of the various header fields, it was able to determine that the operating system is probably Linux 3.11 or newer. There are a number of other signature items that P0F is capable of looking at. If we were able to pull up one of the HTTP connections, you could see it was able to determine the server type, not only the operating system in some cases, but also the web server. So here's another one. It figures out that it is running Linux 3.x, and this is a different server altogether. So there are a number of things you can determine just by running P0F as you are communicating with your target, and you don't have to go through the effort of grabbing packets and digging through the frames individually yourself. You can use P0F to do some of the analysis for you, and then you can just look at the output. And as you can see here, there is a fair bit of output that you've got to scroll through because it does pull a lot of information out of each individual packet. But as you're doing a lot of capturing of data and communication with the different servers, you will find that P0F can help you really sort through some of what you're looking at. And it does this in a passive way by just observing the traffic in normal communications that you are going through with your target. Now, I was talking before about doing packet captures, and so one thing I'm going to show you here is how to actually capture packets. One thing that we can do is we can just run TCP dump, and that's going to capture all of the packets that are coming through the network interface on our system. What I'm looking at here is packets that are destined specifically for my system or ones that are passing across the interface. The only time that we can look at packets that are just passing across the interface is if we put the interface into promiscuous mode. TCP dump will put the interface into promiscuous mode, so we not only see the packets that are just coming to us specifically, but also anything else that's passing across the interface, so broadcast traffic. And if we were on, for example, a hub-based network where all of the traffic goes to everybody, you could see everything there. One of the things that you'll notice here is this is just a lot of output that isn't really easy to read quickly. We're also getting just a lot of output here. What I can do is I can say TCP dump. First of all, I could say -I ETH0. If I had multiple interfaces, I could specify a particular interface I wanted to capture traffic off. I could also say, let's just say we're going to only capture traffic that is from my gateway. So anything that is associated with 172.30.42.1, I'm going to see that. And so you can see gateway is that host name for that IP address. So that's my gateway address. And the only thing I'm seeing now is something from that particular IP address. So I can capture that there. Another thing I could do would be to say port 443. So what I'm doing is I'm creating filters. So I'm only displaying or only looking at the traffic that I specifically want to see. So in this case, I'm looking at HTTPS traffic because that's what comes across on port 443. I could filter out on port 80, for example, if I wanted to look at web traffic, or port 22 if I wanted to look at SSH traffic. Now, I can also ramp up the verbosity, or the amount of information that we're getting. So if I do -v, you'll see we're getting more information there that is being printed out. And so I can add in additional -vs if I need more detail. But still, you've got to be able to read the header information, because what this really is just the headers. You're only looking at the header contents and not the actual data. We can't do that with TCP dump. We need another utility to do that. Now that we've actually looked at doing some packet capture, we talked about how you can't see the data using something like TCP dump. So it's great at capturing traffic, but in terms of doing analysis, it's not quite as good as other programs. And so what I'm going to do now is, first of all, I'm going to capture some traffic using TCP dump, and then we're going to use another program to do the analysis of it. If I do TCP dump -w and then specify a file name, what I'm doing is I'm writing out to that file. Everything that's captured is written out to that file. Now, the other thing I need to do is I need to set the snap length. I'm not just capturing headers or some portion of the packet, I'm getting the entire thing. So if I say 0 here for snap length, then I'm really saying capture everything. I don't care how large it actually is. So at this point, we're capturing everything that is coming through this interface. So not just packets that have been destined for here, but everything that's running across this interface, because TCP dump puts the network interface into promiscuous mode. Now, we've captured several packets at this point because this has been running for a few seconds, and there's probably a fair bit of traffic on here, so I'm just going to kill this. Now, I've got 3,921 packets received. And so what I'm going to do now is I'm going to go to sniffing and spoofing in the menu, and I'm going to run Wireshark. Wireshark is going to, first of all, generate an error because I am running as root, and Wireshark prefers not to do that. I'm just going to click through that. That's okay. It's not ideal to run it as root, but in this particular case, I'm running things on my local network. I don't really worry about the possibility of Wireshark being exploited. What I'm going to do is I'm going to open up the capture file. What I can also do with Wireshark is I can actually capture packets here. So I could specify ETH0 and then just start capturing packets by clicking on the little shark fin there. But I can also just go and open up the packet capture, and I'm going to specify output.pcap as my capture. And now you can see we've got all of the packets listed up here on top. So Wireshark actually does a really good job of pulling the packet apart for me. So I've got all of the different layers here. I've got the frame, which is the physical layer, tells me that I've got an Ethernet frame. And then if I scroll down a little bit, because I popped that open, I've got Ethernet 2, which is the type of Ethernet that we're using here, and it specifies my source and destination MAC address, and also says this is an IPv4 packet. Specifically, it's a UDP packet, and I can pop that open and discover that I've got a source port here and a destination port and then a length. And then you'll notice down at the bottom, every time I click one of these, the highlighted section changes because it's showing me where in the actual dump the bytes that we're looking at are. So this source port happens to be 2 bytes. And you can see down at the bottom, it's DE71. And on the right-hand side of the bottom, we've got the ASCII decode of that. The first one, DE, that first byte, doesn't decode to something printable, but 71 decodes to Q. In reality, of course, we're not looking for the ASCII decode of it because really it's just a number, which is 56,945. So we've got Wireshark, which can really do a good job of giving us the ability to look at our packet capture data, and it does a really good job of pulling it apart for you so that you can see the different components very clearly and easily. Another example here is if we look at the IP header, there are a lot of components to the IP header, and Wireshark actually extracts those out to their own lines, giving you the information in a way that you can read it rather than having to go down and just look at 00CA, for example, and figuring out that that's really 202, and what that 202 means is it's the total length. So Wireshark is a good way of doing visual packet analysis, and Wireshark really does a lot of good things for you. So it may be a tool that you turn to on a pretty regular basis. One really useful skill to have is to be able to interact directly with services. And one reason for that is you want to be able to pull back the banners that applications provide. Banners will give you information about the specific application that is running on a specific service port, and it may actually give you version information. So there's a couple of ways we're going to take a look at how to do banner grabbing. The first one is to use the Telnet client. Now, you may have heard how bad and evil Telnet is because it's unencrypted. What people are talking about when they say that is the Telnet server. The Telnet client is really just a program that opens a TCP connection to a port, and if you don't specify one, it assumes port 23, which is the Telnet port. Now, I can specify a port and override that, and then what I've got is a TCP connection to whatever port I choose. In this case, I am choosing port 21. Now, I have connected to an FTP port, and I could interact with this directly, but what I get out of this is the message that the FTP server has provided, and what that tells me is it's running pure FTPD. Now I could do some investigation on pure FTPD and see whether there are vulnerabilities. If I were to think of this from an adversary or attacker perspective, I'm interested in knowing that you are running pure FTPD on your FTP server. If I type control right square bracket, it drops me back to a telnet prompt, and from here I can just type quit. The other program I want to take a look at here is called Netcat. Netcat gives me the ability to do the same thing, but it also has many other capabilities. Netcat is called basically a Swiss Army knife, and I can use Netcat to open up a TCP connection. And again, I'm connected to the FTP server. I use the same port on the same host, and so I'm really getting the same banner back, so there's nothing surprising there. Netcat also gives me the ability to use UDP where Telnet only does TCP. So if you had a UDP server that you wanted to communicate with, you could say -u, and it would use UDP as the transport protocol rather than TCP. Netcat also gives us the ability to do listeners, so I could set up a listener using Netcat, and it really just becomes a sync. So any connection coming into this host here that I am setting up this listener on just dumps out to the console. So Netcat just doesn't care what is sent to it, it just prints it out for me. So I could create a listener that just acquires information from whoever wanted to connect to it. So Netcat is another great utility to know about. As I said earlier, Telnet is a good option if you've got a TCP host and you just want to open up a raw TCP socket to a port on a system somewhere. So the Telnet client's good for that. Netcat's also good for that, but you can also use Netcat for UDP and also if you want to do listener sockets. Now that I know what tools to use, I can start interacting directly with protocols at the protocol level. Let me give you an example. We're going to talk HTTP to an HTTP server. Just as an example, I'm going to use one on my local network. And I'm going to say port 80 because that's the port that web servers traditionally listen on. That's the well-known port. Now, I have connected at this point, and even though I'm not getting anything back, I know how web servers work. They're actually waiting for me to say something. And unlike Telnet, which will actually tell me when I am connected, Netcat doesn't give me that. So at this point, I just know I am going to say head slash, and the slash is the resource that I am looking to acquire. Slash just means give me the index page at the very top of the website, and I have to specify the HTTP version, which is going to be 1.1. And if I say 1.1, I now have to include a host header indicating what host I want to use. The reason for this is because HTTP 1.1 includes the capability to do virtual hosting, which means a single web server could have multiple sites contained within it. And so I have to specify which one I actually want to get. I'm going to say host and then provide the IP address because I don't have a domain name for this, or a fully qualified domain name rather. So I'm going to give it the IP address. Now you'll see that I hit enter and nothing is happening. The reason is because the web server is waiting for a blank line so that it knows when I am finished sending it requests. So once I do that, it will send me the results. And now I've got the header back from the web server. I can do that, or I can also do a GET request. And again, I have to specify the version number. And once I have said version 1.1, I have to say what IP address I am looking for. Or if you've got a host name, for example, www.blah.com, for example, I could say that. Once I have done this, what I'm getting here is the entire HTML. And if I scroll all the way up, I'll also get the headers back from the web server, in addition to the entire contents of just that page. Now, the way web servers work is what I am supposed to do as a consumer of the HTML is to figure out what other resources I need from this. So I'm not getting all of the images from this, for example. I would have to parse through the HTML, figure out what other document components I need to go acquire from whatever server they happen to be from. But what I'm getting here at the top is the HTTP header. So this is the actual HTTP content, where below this is HTML. So the HTTP is carrying the HTML. And here I've got the server line, which is really important. I know it's an Apache running 2.4.18 as the version, and it also is running on an Ubuntu system. So I've gathered a fair bit of information from looking at the HTTP and interacting directly at the protocol level, so I see the interaction that's happening from the application. Now, we've been through HTTP and SMTP. We're going to take a look at FTP now. The FTP port is going to be 21, so we're going to netcat into our 192.168.86.44 on port 21. Now you can see here that we've got a VSFTPD server, and it's running 3.0.2. So again, we've seen the advantage of going directly to the port and trying to communicate there. Now, in order to log in, I can do a user here, and I need to specify a password. Now, if the FTP server supports anonymous FTP, you could just use user FTP or user anonymous, and then for the password, depends on what it is they ask you for. Sometimes they'll say, give me your email address. Just make something up when you specify the password. So now we can get the status of the server. So you can see that we are connected and we're logged in as bad user with a type of ASCII. The other type, of course, is binary, depending on what it is that we are transferring. We can do things like print the working directory. So my working directory is home/bad user. I can also do things like make a directory. So mkd bad directory. So now I've got a directory there. In order to change into that directory, I would change working directory. And then, of course, if I print working directory again, now I've got the bad directory. So I can also store information and I can retrieve information using these commands. There are a number of commands that FTP supports. These, of course, are some of the common ones. I could get the size of a file. I could also get the system type back. So this happens to be a Unix type system. We've gone through logging in with FTP just using the raw FTP commands, not the same commands that you would use if you were connected with an FTP client. Those are going to be different. These are the raw protocol commands that the client is actually sending off to the server. And now you can use those very same commands by connecting directly to the FTP port and issuing them yourself, just so you can really see what happens when you are connected directly to an FTP server. You're not being filtered through the FTP client and only seeing what the client wants you to see. Now that we know how to interact with servers a little bit, we're going to take a look at another protocol. This one we're going to look at is going to be SMTP, which is the Simple Mail Transfer Protocol. And it's the way that we send messages to an email server. If I've got a client that I'm going to send a message from, so for example, I'm using Outlook or Apple Mail or something like that, I want to send mail to somebody, it's going to send a message to the email server using SMTP. So we're going to use Netcat here. I'm going to open a connection to a server on my local network on port 25, because that's the SMTP port. So I've got a response back from my SMTP server. You can see it says eSMTP, which is extended SMTP. And we're also running Postfix, which is the software that is being used. So I can now say EHLO, which is the extended SMTP version of hello. If I wanted to not use extended SMTP and just use SMTP, I would say HELO. But I'm going to use extended SMTP, and so I'm going to say EHLO, and it looks for an IP address or a domain name or a host name there, and I've just used blah.com just for fun. So now I need to say mail from, and I need to specify who the mail is coming from. Now, this is not the way it's going to look in the headers. The headers are going to come later. So this is just me talking SMTP to the mail server. And I can say to, for example, root at localhost. That's just going to go to the local server because that's pretty much all I've got set up on that particular mail server. This is going to have to be either a mail server on your local network, or in order to have a recipient to, the recipient has to exist on that server you're talking to. So it's either your own server that you have permission to send mail through, or it has to be the mail server of the recipient. Now I've got mail from recipient to, and I can just say data. So here I can say, and then from could be, and then subject. So now I've got a subject, and now I can just type the message. Now, once I'm done, in order to send it, you see the line that says 354 end data with carriage return line feed dot carriage return line feed. That looks like this. So I had a blank line, then I typed a dot, and then I hit enter again, and that's the carriage return line feed. Now I've got the message queued, and I can just quit out of Netcat. So I can also do things like potentially, and this may not work on the server that I am communicating with. In this particular case, verify does work because it says so. So these are actually the commands that are allowed through this particular server. There are other commands as well. These are the ones that are allowed here. Other servers may provide you with a different list, but if you want to just send mail, remember you have to say hello, and then you have to say who the mail is from, and then get a response back saying whether that's okay or not, and then you have to send the recipient, then you can send the data. So that's communicating with an SMTP server. One tool that comes installed by default on Kali that you can also get a copy of, it's a Python script. It's called Theharvester. Now, Theharvester is a program that is designed to gather email accounts, subdomain names, virtual hosts. It can get open ports and banners, may also get employee names using different public sources. It uses search engines and various social network servers, for example, Twitter. It also uses LinkedIn. It will look for PGP keys. So if somebody is doing any PGP encryption with their email, there may be a key that's stored on one of the PGP servers. So I'm going to run this against my own personal domain that I've had around for a couple of decades now. My data source is going to be all, and I'm going to use my domain name, as I said, and I'm going to do a DNS reverse query on all ranges discovered. So basically, anything that it finds is going to do a reverse query on them. I can just run this just as it is. I could also save the results to a file, whether it's HTML or XML. I can also do a top-level domain expansion discovery, or I could do a brute force on the domain name to see if I could find any hosts there. I'm just going to run this, though, just using my domain. So it's looked at the PGP server, it's looked in Google, looked in Bing, it's looking in Exalead, and so far it's turned up some email addresses. Some of these just don't make any sense to me. None of these are mine except for the second one. So somebody else is using my domain and publishing a user email using my domain somewhere. That's not terribly uncommon with this particular domain. So you can see it's doing a lot of automated analysis for you. Other domains obviously are going to turn up more information than my small domain, even though it's been around for a while. But the Harvester does all of this in an automated fashion. It's got a number of functions that you can make use of, and it's just a Python script. So it runs on Kali Linux. It also runs on Windows if you've got a Python interpreter installed. So you can see that it will do a lot of work for you. And in this case, what it's turned up is a number of reverse DNS queries for the IP address for my website. There are a number of other domains that share that particular IP address as well. The Harvester is a tool that you can use as you're going through your reconnaissance stage and maybe turn up a lot of information that would be more tedious to do in a manual fashion. We're going to look at another automated tool that's capable of doing some reconnaissance for us. This one is called Recon-NG. This is actually going to work quite a bit like Metasploit, and we'll take a look at Metasploit later on if you're not familiar with it. It really is, though, designed with the same sort of interface in mind, and let me show you a little bit how that works. The first thing we can do is just type help, and you'll get a list of all of the commands that are available to us. So we can add records to the database, we can exit the current context, we can load specified modules, we can record commands to a resource file. The one thing that we really want to take a look at here, though, is the command show. I want to show the modules that are available to us. So these are modules that we can load up, and you can see that there are exploitation modules, import modules, and then there are the recon modules. You can see that there are ones that are related to Bing and Indeed, and you can see that there's GitHub Miner and Whois Miner, and there are a number of others. Recon-NG uses APIs from various search engines, and in order to use those, they use API keys. You can acquire an API key and plug it in here so that Recon-NG can work directly with the API from Bing or Facebook or GitHub or Google or so on. However, we're going to use a couple of modules here just to show you how this works. One of them that I can use is actually one that relates to Netcraft. And Netcraft is a website that gives us details about websites and the technology that they use. In order to make use of this, we just say use. I'm going to paste that in. And now I want to show the options that are available. The only option that is really available to us right now is source. So that's the only option that is necessary for this particular module to work. Currently, the value is Microsoft.com. That's the one that I was playing with recently. Otherwise, it would just say default and there wouldn't really be a value there. We could change that by saying set source, and then we could say O'Reilly.com, for example. And now all I've got to do is say run, and it's going to go query Netcraft, and it's going to do that automatically. So I don't have to go to a web page in order to do that. I can just use Recon. There are a number of other modules that are available. You can look through Twitter Profiler. We could look at YouTube, for example, or here's one called SSL Tools, and we can take a look at this one. And now I'm just going to say use in that again, and you can see the context has changed, where before we were in the Netcraft module, now we are in the SSL Tools module, and I always want to see what the options are going to be for us. And in this case, it looks like we've got two options. One is restrict, and then the other is source. So I'm going to say set source. I can just run this. I can get information about the SSL certificate that was available for the host O'Reilly.com. So there was no common name found in the certificate, and there was no subject alternative names found for the SSL certificate that's apparently in use at the hostname O'Reilly.com. So Recon-NG is another utility that we can use to automatically gather information that we may be able to use against targets. There's a protocol that used to be used far more often and was actually exposed a lot of times, and it ended up causing problems. This was the Simple Network Management Protocol. While SNMP is still in use, it is far more locked down as a general rule than it used to be. However, you may still be able to find devices that support SNMP, and even though SNMP used to be far easier to interact with than it is today if they're using up-to-date versions, it's still worthwhile knowing how to use SNMPwalk. So the very first thing that we're going to use is we're going to use version 1, which is the really old version, was deprecated a couple of decades ago, except that there are a number of embedded devices that may still support version 1, and there really are a lot of devices around that still use it. And you can still turn it on, as you'll see right here. 192.168.86.41 is going to be my target. So I'm specifying version 1 right there. And then version 1, in terms of authentication such as it was, there were community strings, and typically they were public and private. Public meant read only, and private meant read write. But since this was what everybody implemented, wasn't really anything in the way of any sort of security. Certainly there was no encryption, and this is very, very weak authentication. I can do SNMPwalk, and what SNMPwalk does is it connects to the SNMP server or the SNMP daemon on my target system, and then just walks through every variable that we can get from the SNMP server. So let me slow this down a little bit, and we can see what we can get. So the very first thing that we can get is really the uname string. This is a Linux system, and this is the host name, and then we've got the kernel version, and then you've got the rest of the information about when the kernel was built and the type of kernel that it is. So now we've got the number of days that it has been up, and then there are a number of other strings that we can see. We can see the boot image that was used here, and really that's kind of apparently all we get out of this particular system. Other systems will give you things like interface information, for example, so you can get the number of interfaces out of it. So that's version 1. Now, version 3 is a little bit different. So with version 3, we've got some options here. I'm going to specify authentication, but no privacy. And then I'm going to say that the user is auth only user, and that's specified in the SNMP configuration. I'm going to give my password here. Again, this isn't a great password, but that's my authentication string that goes with the user. And we're going to use MD5 to send the password over. So we're not just sending it in the clear, we're hashing it first. And then finally, we've got our target IP address. So I can provide that, and it looks a bit like we got more information out of version 3 than we did out of version 1. So again, we see the same thing here that we did with version 1. And here is where we've got the interface information. We've got the loopback interface, and then we've got a number of counters with variables here. If we were to look up this OID or object identifier, we could determine exactly what this counter 32, meaning 32-bit variable, actually told us, and then we could figure out what the value here is. We can just kind of keep flipping through. You can see that we've got some IP addresses here. So here are the IP addresses that are configured. This is going to be the default gateway for this particular system. So this is the loopback address. This is the interface address. And then we've got the network mask for the IP address, and then the network mask for this IP address here. And then we've got the network address itself. And so we can just kind of keep flipping through, and you'll see all of the data that has been provided to us very nicely by the SNMP server. All I had to know was the authentication information, and this particular server gives out more authenticated information than it does just public information. So Snmpwalk, as you can see, can be a really valuable tool, and you can use it for any of the versions, whether it's version 1, version 2, or version 3. Version 3, you may have to do encryption in order to communicate with the SNMP server, meaning privacy, or you may just have to know the username and the password and then just know whether it does MD5 or SHA-1 or something like that. Snmpwalk is a great utility in order to extract information from systems that are actually running an SNMP daemon. Now we're going to use another utility here for reconnaissance, and this one's Dnswalk. Dnswalk checks for zone information on DNS domain names, and it does that by attempting to do transfers. So what we're going to get by doing this is probably a number of errors, because most domains actually have zone transfers turned off by default because they don't want somebody doing this. So what we can do here is we can just say O'Reilly.com. Now, it's important to end with a dot here because that's the way DNS works, and we're saying dot because we're just saying that's the end. There's nothing more after that. So I can do Dnswalk, and I'm going to get zone transfer failures. We're trying the different domain name servers that this particular domain has been configured with. I can also specify we're going to do recursion in order to look for subdomains of this particular domain. So if there were a subdomain like this, for example, it would look for those. So we could say -R. Again, we're going to get zone transfer errors. And I could try this with another one. So I could try this with my own domain. And again, I can tell you that we're going to get errors because, as I said, most domains have transfers turned off because they don't want people just walking the entire domain to pull out all of the host information that is within the domain. That's not to say that every domain is going to be like this, however. You may be able to use Dnswalk against your target domain, or if you happen to be doing this from within the network, DNS zone transfers may be turned on for particular network ranges. Just because we're getting errors here is no reason to discount this tool. It's still worth trying out just to see if you can get information about your target if they do have zone transfers allowed from anywhere. It is worth trying this out so you can get every host name that's available in the IP addresses that are associated with it if you can get Dnswalk to work against the domain name target that you are going after. Before we get talking about port scanning, it's probably useful to talk a little bit about ports. We've actually been using ports without really talking about what they are. Now, when you're doing network communication, you need a way of addressing the system that you are communicating with, just as when you're mailing a letter, you need to put an address on it. In the case of the systems that we have been working with, we've been using IP addresses. Well, that's one way of addressing a system. You can think of this maybe as a zip code. So, a zip code will get you to a particular location, but beyond that, you need to know exactly where it is that you need your messages to go. That's why we use ports. Ports give you the ability to address not only a system, but a particular application. So on this system, for example, we've got some services that are listening, actually, really only one service that's listening. And in this case, this is a DHCP service that's listening. We've got a port here. And if I change this a little bit and say -n for numeric only and then go back up, you can see that what we've got here is listening on port 68. So that's the port that is being listened on. Now, as we're going to go through port scanning, we're going to be communicating with ports in order to determine whether they are open or not. An open port means that there is an application listening and that port is available to communicate with. A closed port means that there's nothing listening on the other end, and so there's no way to communicate with anything. Even though we know, for example, port 80 is a web server, if we try to communicate on port 80 and nothing responds on port 80, that means there's no web server listening at that particular service. We're also going to run into cases where we may see filtered responses coming back from our port scanners, and that could mean a couple of things. It could mean that there's a firewall which is blocking the response back because when we are communicating doing port scanning, we expect responses back. So we either expect something that says, yes, I'm open, or something that says, no, I'm not open, go away. If we don't get anything back at all, we don't really know how to interpret that. It could mean that there's something that's open and it's just not open for us in particular because a firewall is blocking our IP address. Or it could mean that the message got lost, for example, and just never got through. If that's the case, if we don't get any response at all back, then it may say that it's filtered. So we're going to see open, closed, and filtered as we do port scanning. Just keep in mind that the IP address is how you get to the system. The port is how you get to the application that is listening on that system. The port scanner that we're going to start off using is Nmap. Nmap is a program that has been around for quite a while now, for 20 years, give or take. It's called Nmap because it's a network mapper. The purpose of using Nmap is to be able to determine what systems are up on a particular network and what ports are listening on that network. Contrary to movies like The Matrix, for example, I know I'm going back a little bit in my references here, but Nmap is not used to directly break into systems, even though there have been various movies and TV shows suggesting that Nmap is capable of doing more than it really is. But we are going to use Nmap here. Now, the first thing that I'm going to do is I'm just going to get help for Nmap so we can see what sort of capabilities we are dealing with. So when I issue help, I get a list of parameters that I can pass to Nmap to do various functions. So for example, I could do a list scan. We could get just a list of targets that are available to scan. We could do a ping scan, meaning you're just going to ping the host to see if it's up or not, and we're not actually going to do a port scan. We have other capabilities when it comes to scanning. We can do a number of TCP related scans. For example, you can see there's a SYN scan, a Connect scan, an ACK scan, a Windows scan, Maven scan, and then there are some other ones down here, null, fin, Xmas, and so forth. There's also just one UDP scan. The reason that there's just one UDP scan is UDP doesn't have all of the overhead that TCP does, so there aren't a bunch of flags that we can set. And you can see here that you could actually specify scan flags and customize exactly which TCP flags you want to turn on. So there are a number of scanning techniques that we can use. We can also tell Nmap what ports to scan. Ports on a system go from 0 to 65535. 0 is not used, but in terms of the value for the 2 bytes that are used for the port number, that is a value that can be selected. It's just nothing is ever going to be there. It's not a valuable port to check on. So you can say 1 through 65535, and that will scan everything. If you just don't specify, then it's going to do roughly 1,000 ports that are the most commonly used ports, and that saves you some 64,000 ports from scanning, because that can take a long time to scan that many ports. We can also do service and version detection. We can use scripts to scan, and we'll get into some of those a little bit later on. But you can see just some of the capabilities here that we can use when we are doing Nmap scanning. It has a lot of capabilities in terms of determining what is actually available and listening on the systems that we are targeting. So now that we've got a background on Nmap and what ports are, let's take a look at actually doing some scanning. So the first thing I'm going to do is say Nmap, and I need to determine the type of scan that I want to do. So a common scan is a SYN scan. Now, what a SYN scan does is it sends out a SYN message or a synchronized message to the target system using the TCP IP stack and the first part of a 3-way handshake. What we expect back from an open port is a SYN ACK. So what the target system is saying is, I acknowledge your SYN and I send a SYN of my own. This is sometimes called a half open scan, because what happens at that point is we just reset the connection and we never finish the 3-way handshake to complete the connection. What I can do is I can say 192.168.86.1, which happens to be the router on my local network. It shows that there are 3 ports that are open and there are 997 closed ports. As mentioned before, we could say -P1 through 65535 and just scan everything. The shorthanded way of doing that is to just say -P-, and that says scan all of the ports. So we're doing a SYN scan on that host. Now, you may be thinking here that we're just scanning one host, and that really gets kind of tedious if you need to do one host at a time. I don't, though. I could do a couple of different things. So I could use classless interdomain routing notation or CIDR notation, which indicates the number of bits in the subnet mask, in this case 24. So that would be 255.255.255.0. And I could say I'm going to scan the entire network here. And I'm not actually going to scan all of the ports on the network. I want it to go a little bit faster than that. What I can do there is just say I'm going to scan everything, and now I'm going to get responses from all of the hosts on the network so that I can see what all of the hosts on my network are. So this is actually going to take some time because there are a number of hosts, and it's going to take a while to even go through the hosts that don't exist, because there are going to be IP addresses that we check and there's not going to be anything there, but we're going to check them anyway because we don't know. So we do pings in order to determine whether they are up or not. And if they aren't, then we don't bother checking. But one ping may not tell you whether a host is up. So anyway, there are retry attempts, and it can take a while to scan an entire network. Another way of doing this is I could say let's say 40 through 45. So I'm going to scan just IP addresses .40 through .45. And in this case, I've got two responses back. So I've got 41, which tells me that it's a VMware host. And I've got .45, which says this is a Sonos host. What Nmap is doing is it's looking up these first three octets from the MAC address, and it's using the organizationally unique identifier there, those 3 bytes, to determine what the vendor is. So these 3 bytes will tell you what vendor owns that MAC address. So there's nothing magic here. It's not getting this from the host itself. It's doing a lookup from the 3 bytes in the MAC address. You could do a range of IP addresses, or you could do an entire network using, as I said, the CIDR notation. And that's a couple of ways that you can do more than one host at a time when you're doing your scanning. What I showed you last was a SYN scan or a half open scan. All of that does is it sends a SYN message, waits for a SYN-ACK or a reset back, and determines whether a port is open. Sometimes that's considered impolite because you're maybe leaving systems with half open connections. Theoretically, the reset should take care of that, but still, it's better to do the full connect and then drop it, because what you could do is you could trigger an alert with respect to port scanning by sending all of these resets because somebody may notice. So there may be reasons why you want to do a full connect scan. We can do that using minus lowercase s, capital T, and then 192.168.86.1 again, because I know that host is up and will respond with ports that are open. So again, I didn't specify a port range. I'm going to be okay with the roughly 1,000 ports that Nmap uses for default. And again, we get the same ports back, not surprising. In essence, we're doing the same thing that we did before. We're just adding a different message in than we were. So rather than the reset, we're sending an ACK back to the SYN-ACK. And then later on, we're sending a reset saying, no, never mind, I didn't really mean to do that connection. That's one other way of doing a TCP scan. There are a number of others as well. You could do a FIN scan. FIN is the flag that gets set when connections are torn down. And again, there is specific defined behavior for an open port when it receives a FIN message where there isn't an open connection. So here's where we get the open filtered, because we got a response suggesting that it's probably open, but the response may also indicate that it's filtered, just because the response isn't definitive in terms of how TCP has defined that response. You could get the same response if the port was filtered as well. We think it's open, but Nmap is saying it could also be filtered because that response that we got could go either way. That's another type of TCP scan. Another one is the Xmas scan. So that lights up 3 flags in the TCP packet. And again, because of the response that we've got, we're not really sure whether it's open or whether it's filtered, because these are odd packets. When we send a Christmas tree packet or an Xmas packet, what we are setting is the FIN, urge, and push. Urge says this is an urgent message, get it up to the application immediately. Push says don't bother buffering it all, just send it up. And then the FIN says we're actually closing the connection. So this is something that you wouldn't typically see. And certainly this is not something you would see if you don't have an open connection. So again, we're getting responses that suggest it's probably open, but we may also get the same response if there's a firewall in the way. So Nmap is telling us that it could be filtered, but it could also be open. Those are some different TCP scans that you could use. As you can see, they all give us basically the same results. We've got the same 3 ports that are indicating open. It's just that the oddball scans, the unusual scans, are telling us, well, it could be filtered as well. You kind of have to know what it is you're doing and whether you expect the result to be open or whether you think that there's a firewall. So that may take additional probing to figure out what's actually going on there. if you happen to be using these scans where you're sending unexpected messages through to the end system. We're going to take a look at UDP scanning because UDP is another transport protocol. We're going to take a look at how you would do a UDP scan. If you know UDP at all, you may not be surprised to discover how easy UDP scans are. There's really only one way of doing it because there really aren't any header values to change. We're just going to say 192.168.86.1, and we're going to get responses back. The thing about UDP is there's no defined behavior for open or closed ports. It's entirely up to the application. So what happens with UDP scans is we send out a message on a particular port, and we don't really know whether the lack of response means that there's no application or that we just didn't get the message right for the application to respond to us. As a result, what happens is we keep sending out messages. You can see the scan is taking quite a bit more time than the TCP scan simply because we have to keep retransmitting. Now, I can alleviate that, and here's a good opportunity to show you this. I can use -T, which is the throttle, and I could really open up the throttle to, say, 5, and that would go faster than we were doing it before. And in this case, we're going a little too fast because it's telling us that we've got a retransmission cap hit. What we could also do if you wanted to, and this may be useful on, say, a TCP scan, is you could turn the throttle way down to, say, 1, and that would go really slow, so you may not get picked up by intrusion detection systems, for example. So you can use the -T whether you're doing UDP or TCP scanning. It just is an indicator of how fast you would like the scan to go. Now, UDP, as I said, is a slower scan technique simply because there's just no definition within the protocol for how an open port on the system should respond. It's entirely up to the application, which is why this has been running for a while. So what we got here was we've got one that appears actually to be open, 928 that we got some response, and we can't really tell whether it's open or filtered. It's probably not open. And there are 71 that Nmap was able to determine are definitively closed. So if you wanted to see the difference between that, you would want to do a packet capture and look at the responses that it got, or you could certainly read the documentation in Nmap to determine why it flagged 928 as open or filtered and 71 as closed. But bottom line is you can see that UDP scans can take more time. We're still only doing about 1,000 ports that it's scanning. And it does take more time because we're doing retransmissions to determine whether the port is actually open or closed or whether it was just lost in transit, because UDP has no capability within the protocol to determine whether a message was lost or not. It relies on the application for that. A system is just going to send a UDP message out. It could be dropped in the network somewhere, and the sending system would have no idea what happened to it because there's no tracking mechanism. So that's a couple of reasons why UDP scans tend to take longer than TCP scans, but it also makes for very simple scanning because it doesn't have all of the overhead of TCP. You can just use -SU to do UDP scanning, and that's the only type of UDP scanning that you can do and need to know about. Now, we've looked at some different ways that you can scan using protocols like UDP or TCP and finding open ports. That's not all Nmap can do, however. Nmap has the Nmap scripting engine, which uses Lua as its programming language. So there are a number of scripts that just come installed with Nmap, and we could do something like -SC to say we're just going to use a script scan using just a default set of scripts. So this is the same as doing --script equals default. And now I could do 192.168.86.1 here, and we're going to scan that target using the scripts that Nmap comes with, and there are a number of default ones that you can use. So you can see that using scripting, we get some additional information here. It looks like bind is version DNSMask 2.72, and the HTTP title is Google Wi-Fi. So we've got some additional information because as open ports are found, they get handed into the scripting engine to the scripts that are running, and those scripts can then get additional information, for example, probing the port to get the banner or version number or whatever else the script has been set up to do. We could also say nmap -- script, and we could say anything that starts with HTTP, we are going to run. And again, I'm going to say 192.168.86.1. So we're going to run all HTTP scripts that Nmap comes with. That's not all we can do, though. Scripts actually get categorized. So you could, for example, I'm not going to wait for this to finish, but I could say -- script and also provide a category. So I could say default or safe here, for example. 192.168.86.1. So we're going to run all scripts that have been categorized as either default or safe. And those scripts are going to run as the relevant ports are found open and they get handed in. Now, I could run scripts that are intrusive. I could say not intrusive, for example. You can also build your own scripts. You don't have to be limited, not to say that the scripts that come with Nmap are limiting in any way. They're very extensive. There are a lot of them, but you don't have to just live with the scripts that are there. If you've got something very particular that you want to do, you can write your own script, and we're going to take a look at writing your own script coming up. But you can see now the varied information and the very detailed information that we can get using the scripts that Nmap comes with, just the ones that are there without me having to do anything additional. The scripting engine that comes with Nmap and all of the scripts that just come with Nmap are very powerful tools as you are doing your scanning, and I would definitely recommend that you make use of the scripts by providing scripting parameters into your scans to make sure that you're extracting the most from your scans as you possibly can without doing anything additional, because Nmap is just going to take care of all of that for you. And then once you've got the information, then you can go on and continue your targeting and the remainder of the testing that you're going to do. Now, on top of using the scripts that come with Nmap, and as we've seen, there are some scripts that do very detailed things and extract a lot of very relevant information for you. On top of those, you can write your own. So we're going to take a look here at a script that I wrote some time ago just for the purposes of demonstration. It doesn't do anything very exciting, but you can see that you can write your own, and it's actually pretty easy to do. What I did was I took some scripts that already existed and cobbled together my own to do something. And it's really fairly easy to go in, and if you know scripting or programming languages at all, you should be able to find scripts that do something that's similar to what you want to do, and you may be able to just cobble those up and edit them around so that you've got a script that does something very specific for you. What we've got here is a script that's going to connect to a UDP server and then determine if there's anything there. And in this case, I've got a very simple Python script that's running on a particular port. And in this case, what we are looking for is port 9876. So basically, we set a rule here saying if 9876 comes back as open, open filtered, or filtered, as we are doing the UDP scan, we should get that. What this does is it tells the scripting engine, hey, if you see something that has port 9876, that should come to me. Now, we specify a function. We then say that we are going to send a UDP payload. So we're going to send a UDP payload doing a new UDP socket, and then we're going to just set the timeout. Don't really care what the timeout actually happens to be, but then we're going to connect to port 9876. And if we don't get a status back, then we're just going to return. If we do get a status, then we're going to send our payload. And the payload is going to go to the server. And again, we're going to check to see if we got something back. If we didn't get anything back, then we are going to just quit. If we did get something back, then we're going to close out the socket and we're going to return the data. And if we get all the way to this point, we've actually got something that has responded. Again, this doesn't do anything particularly fancy or exciting here. But what we can also do is we can make sure that not only do we send the data when we connect, we can also check to see what it does. So we're going to say our payload is hello, and we're going to send that payload off. Then we get the response back, which is what we sent back to this function here. We're going to see whether it equals hello in all capital letters. If we get that back, because what we've done is we've sent hello, and the script that I wrote up just capitalizes everything and sends it back. If we found that we've got a server that capitalizes our payload and sends it back, then we have found our server. So in this case, what I'm going to do in order to run that is I'm going to do a UDP scan. And I'm just going to say ports 9870 through, let's say, 9880. And then I'm going to say script UDP test.nse. And then my target is going to be 192.168.86.23. In this case, we've got a lot of closed ports because we specified the ports, and so we specified exactly what ports we want. Nmap is telling us that those ports were closed, except we did find one that was open, and we get the response back saying, found our server, which of course is the message that we sent back. We return a string that says found our server, and then that's what Nmap prints out. Whatever string you return, Nmap is going to print that back out when the script runs if we actually get success. And of course, we did get success here, so that's what we saw. Again, this is just a very simple demonstration of using the scripting engine to develop a script for Nmap. There are a lot of scripts that come with Nmap. You can find them. They are typically going to have the .nse extension, so you can locate those, and reading through them, you may be able to pull together something that actually does a particular function that you are looking for a particular service that may be homegrown on the target network. And so you can use the script to maybe extract additional information from that service. Now, you've got a pretty good handle at this point on how to run Nmap scans. What you probably want to do, or what you may want to do certainly, is you may want to save the output. There are a couple of reasons for that. If we save the output, we can import that output into different tools. For example, Metasploit will take Nmap output, and we can import Nmap into Metasploit. We're going to run some scans here, and then we're just going to output them to particular files. Let's use the scan that we just used. So once we've got our scan, now we can tack on, and this can actually go anywhere. I'm just tacking it onto the end. So I'm going to say -O capital N, and this is going to be output.nmp. Doesn't really matter what the extension is. So this is going to be normal output. So I'm going to get my response, and you can see that I've got output.nmp. And this is just a plain text normal output that actually tells us what the command line was at the head of the file. Now, I can also do XML output. So if I just change the capital N to a capital X, and then we'll actually do .xml here. Now we can say output.xml, and there's the XML. The funny thing about security folks and programmers, probably specifically, is there is generally a pretty decent sense of humor amongst them, and sometimes a bit of an odd sense of humor. So the guys who wrote Nmap got a little bit of grief very early on from a particular class of folks. And so they created this particular type of output. And I'm going to generate that, and then we can say dot L3T. And you may be able to recognize how this has been encoded. This actually is a bit of a joke. You would probably never use this unless you just wanted to be funny or send it off to a friend or whatever. But this is an output option. You can also do greppable output. So I could change this to -G, and then we can say output dot L3T, overwrote that. And so this is greppable output. So it's structured in a way that you could use grep to search for information within the file. This is really helpful if you've got a lot of output and you want to be able to extract particular pieces of information from it. So there are multiple types of output formats that Nmap will support. You're probably going to use, say, the XML or the normal on a regular basis when you want to input into another program. Probably the XML is going to work better for you there because it's very well structured and it's easily readable by the program that you may want to interface with. But if you just want to store output for your own purposes, you can pick whichever of these is going to suit you best. Now, we've taken a look at Nmap, and Nmap is really kind of the venerable port scanner. It's the one that people generally go to if they need a port scanner. The thing about Nmap, though, is there are sort of limits to how fast it goes. And there are other programs that will do scanning faster than Nmap will. And certainly you can control using the throttle parameter that we had talked about earlier. But if you really have a large number of hosts that you want to scan, you may look at something like mass scan. Mass scan allows you to specify the rate at which you are going to send frames out or packets out. We can do something like mass scan, and in this case, I'm going to say --open --banners, and then -p, let's say 21, 22, 23, 80, 136, 137, 445, 443. And then we're going to say --rate equals, so that's going to be 100,000 rather than 10,000 packets per second. We're going to say 100,000 packets per second. And then this is going to be 192.168.86.0/24. We've turned up 3 very, very quickly on those ports. And you can see that we forced the options -SS. So basically we forced a SYN scan, and then this says no ping. So basically these are very similar to Nmap parameters, and there are a number of Nmap parameters that will work with mass scan. I mean, why reinvent the wheel, particularly when people are very comfortable with them? So you can see that here are all of the different parameters that mass scan supports that Nmap also supports. You can say -pn and then -n, never do DNS resolution. So that will speed things up by quite a bit because we're not going out to do a DNS query to figure out what the host name is for the IP address. And then, of course, we can specify port ranges and the scan techniques. We can do a SYN scan, which, of course, is the default here for mass scan, as it says. You can see that we have got the ability to take what we know about Nmap scanning and apply it to mass scan to be able to do scanning at a much faster rate, as I said, which is really useful if you've got a very large network that you need to scan. Mass scan may be able to get you through that scan faster than Nmap may be able to. We're going to take a look at another tool here, and this isn't necessarily useful for port scans in a traditional sense, What it is good for, though, is creating packets on the command line and sending those repeatedly so that you can get responses back. And that may not make a lot of sense. So let me actually just show you, and then we can talk about it as I'm going. I'm going to get some verbose output. I'm going to set my SYN flag, and then I'm just going to say my port is going to be 80, and then I'm going to say my target is 192.168.86.1. So you can see what's happening here is it's sending out a message with the SYN flag set and then paying attention to the responses back. So here, and let me just kill this. The length is 46, the IP, we've got the time to live, the don't fragment bit is set, ID is 0, type of service is 0, IP length is 44, we've got the source port, and then we've got the flags, and this is on the response back. So remember, when we send a SYN, we expect a SYNAC back, and that's exactly what we got. We got a SYNAC back, and the sequence number keeps incrementing. The window size remains the same. We've got a round trip time as well, the sequence number, the acknowledgement number, and none of these should have anything to do with one another. They should all be random because really it's going to look like a number of different initiations of connections that are happening. So every time we send a SYN, it's a new connection that's happening. The other thing that I can do here is rather than the SYN, let's send the FIN flag. In this case, I've got the F set, and we're not actually getting a response with just the FIN flag set. We've got nothing there. What I can do also is I could say -S, -A. So this is the SYN flag, the ACK flag, and the FIN flag. And then we're going to, again, just send it off to port 80. And in this case, we are getting a response back. So what we get back here is we get a reset message for every message that we send. And again, we get the same detail that we got initially. We get some good detail that way. Now, I can also do just a regular ICMP. So I could say ICMP, for example. And in this case, we're just sending out an ICMP message just as you would with a regular ping. And so that's an echo request. And it looks fairly traditional, just as you might expect a regular ping to look. So I could also do UDP, and I could specify UDP here, for example. And in that case, I might specify a port number. I can change my source address to be a random address. So we're going to spoof our source address so it doesn't look like it's coming from me at all. And say that we want some data to go along with it as well. So basically, using hping, you can specify to a very minute level of detail exactly how you want your packet to look, and then you can send it off repeatedly to the host. This works out really well as a great tool just to interface with systems at the port level with different protocols to see how they respond, and you get very detailed responses back from hping. As I said, it's really not necessarily a port scan tool, although you could sort of create scripts around hping to turn it into a port scanning tool, but it is if you've got targeted ports that you want to interface with and you want to get really detailed information back at the protocol level, you can use hping, and it's great for that. So you probably noticed that we're running Windows instead of Linux, and we're going to use a GUI application here. I'm going to show you Zenmap, which is the graphical user interface that comes along with Nmap. I'm going to open up my Nmap folder here and then just open Zenmap. So Zenmap is going to just give you a simple interface to Nmap. You're still going to do scans really the same way that we were doing it before in terms of the command line. It's just that Zenmap will help actually create the command line for you. 192.168.86.66 is going to be my target, and I can select different profiles. So I could do a quick scan, and you'll notice that we've actually changed the command line here. So every time I select a different profile, what I'm going to do is I'm going to change the command line because I'm going to tell Nmap to do something different. I could also do just the same thing that we were doing before. So I could do minus lowercase s capital S, which is a SYN scan. That is not one of the profiles that's offered, but I can just edit the command line. I'm actually just going to use an intent scan with no pings, and I'm going to just say scan now. What we also get here with using Zenmap is we get some visualization tools. We've got the results here, and you can see because we used -v, it's telling us a little bit more detail. So we've got the discovered open port, and we've got an entry for every port that was open. So now what I can do is once we've got the results, because we're doing a service scan, you can see that it's done a bunch more than we had done originally because it did a minus capital A, which is just basically do everything. And the minus capital P lowercase n is don't do a ping. So we're not going to do a ping at all before doing the scan, but we are going to look for services here. And we did discover some open ports. What we've got once everything is complete here, and this will take a little bit of time because it's doing a number of different types of scans kind of all at the same time. What we get though is we get a list of the hosts and a list of the services once everything is complete. We'll also get a list of the ports and the hosts. So basically, this is a tabular version of the output that we were getting before. Now, if we were to scan a number of hosts rather than just a single host, we would get a topology here. And once we've got a host that has been completed, we would get host details. So in this case, this one is running and it will run for a little while longer. But you can see that you can use Zenmap to not only do Nmap scans for you, but it will also provide you with a little bit of graphical output that you can get some visualization of the network and get a list of the services and a list of the hosts that have been scanned, and we'll get the topology host details. And as you run these for a little while, you'll get a list of the scans that have been run as well. So now we've actually run a Zenmap scan, and we did the minus capital A. We did run a higher throttle than it would normally run, but you can see because it's complete now, we've got the operating system is actually Linux. This is Penguins here in the left-hand column, and then we've got the host, which is the IP address. So I can scroll back up and take a look at all of the output. You can see that we've got the ports that are open that we got the list of here where it just said discovered open port. But we also ran some scripts automatically, and we did a little bit of banner grabbing. You can see here that anonymous FTP is allowed, and this is running OpenSSH 4.7 patch level 1 on a Debian system. So you can see the output is fairly detailed here that we get from running all of the scripts that are available. We did a little bit of checking on the NetBIOS results. So we've got a name of the system and also the work group that it belongs to, which happens to be work group. And we get a little bit more detail about the operating system that's running. Now I can also go over here and go to ports hosts. And now I've got the tabular output, and we've got the port. We've got the indication as to whether it's open or not. That's the green dot on the left-hand side indicating that it is open. We've got the protocol in the third column and the state, which goes along with the far left column there. In this case, it says open. And then we've got the service name, which is the name that goes along with the port. If it's a well-known port, that will get automatically filled in. And then because it grabbed banners, we get the version number as well. Given the fact that this is a tabular format, we could sort by any of these columns here. You can sort by the state, you could sort by the service, And of course, this is going to be alphabetical order. And we could sort by the port number as well. Now we've got the topology here, and because there's just one, we've got a single host, but we do get some host details here. This is a Linux system running kernel version 2.6.9 through 2.6.33, and Nmap is 100% sure that that is the version of the operating system. We've got the sequence number, we've got the IP ID sequence, and then we've got the timestamp sequence as well. So Nmap was able to extract a lot of details for you and just provide it very nicely in a summary page. And that is one of the advantages of using Zenmap. Now, I'm running this on Windows, but you can also run it on Linux or Mac OS or any operating system that you can get Nmap running on. More than likely, you should be able to get Zenmap as well. So let's talk about the difference between vulnerabilities and exposures and exploits. Vulnerabilities and exposures are really just areas where you may have weakness within a system or a network. So that would be a vulnerability. And if you've got a vulnerability, you have some exposure because of that vulnerability. When you've got a vulnerability, if somebody were to trigger that vulnerability and say, get into your system, that would be an exploit. Vulnerabilities don't always necessarily have exploits. Sometimes you may have a vulnerability that is more theoretical than it is anything else. You could have something that technically is a vulnerability. So, for example, you may have a sequence of events that has to happen in a very particular order, and the timing has to be just right. So, technically, it's a vulnerability because it could get triggered. The level of difficulty to trigger a vulnerability may be really hard. So just because you've got a vulnerability doesn't necessarily mean that there is an exploit. This database here is hosted by MITRE, and you can go to cve.mitre.org. That's MITRE, not MITER. If you go to cve.mitre.org, you will get to this place, and you've got the ability to look at the entire list of CVEs, so all existing CVEs. You could search for a particular CVE. So let's just say we want to look for vulnerabilities within Apache, and you've got a list of all of the vulnerabilities. If you happen to find a vulnerability, you could request a CVE ID, and you would get one of these CVE numbers. So let's just take a look at this, for example. This happens to be an issue that was discovered in Pivotal Springs security. So this happens to relate to Apache. This is not something that is specifically in the Apache web server. There is a difference between vulnerabilities and exposures and exploits. If you go to the CVE database website here at cve.mitre.org, you're going to be able to search through those. And we're going to be looking at scanning vulnerabilities. And I just want to make sure that you understand the difference between vulnerabilities and exploits. They are not the same thing. There is a difference between a vulnerability and an exploit. And we're going to take a look at doing vulnerability scanning. And we're going to start with a program called Nexpose. Nexpose is a product by a company called Rapid7. And this is something that you can get a community edition for if you were to go to the Rapid7 website. You could go to rapid7.com, and we can go to the products tab, and we've got Nexpose right there. And as I said, there's a community edition that you can download for free if you are doing non-commercial work or something that's just personal. So this is something that you could use at home as you are learning. Once we've got it installed, I'm going to go to the website localhost 3780, and I'm going to get a certificate error. I'm just going to say continue. It's pretty common with self-signed certificates. We're going to bring up the Nexpose dashboard. and we can get started doing a scan once we have logged in. So I'm going to log in with my account, and I'm going to get to the dashboard where we can start creating scans. When you do the install, you will be prompted to create your own username and password that you are going to use for yourself. Everything is running on your local system here. There's a database that runs, and everything is right there. You're going to have your own username and password that you're going to log into locally. Now I've got Nexpose Community Edition open to the home page for this particular web application. And what we've got here is a dashboard that gives us some visibility into what we've done over time. In this particular case, we've got just a single asset, and there was only ever one scan done on this particular implementation of Nexpose. So what I'm going to do is I'm going to create a site now. And once I've created the site, I can start working on developing a scan. So I'm going to say my name is going to be home, and I could plug a bunch of things in under organization here as well. Since there are no other users that are installed here, I don't have to worry about access. I can go to assets, and now I'm going to say 192.168.86.66. And that's the only thing that I'm going to include here. So I've got one asset. For authentication, I can create credentials, and we're just going to say my credentials are going to be SSH. I have to say the account is for an SSH account, and I can say MSF admin and then type the password in and then confirm the password. And I'm going to say that the permission elevation type is going to be sudo, because if I use the sudo command, I can get root privileges. So I can create my account there. So now I've got an account that has been created so that Nexpose knows how to log into this system. If I give Nexpose an account to log in, it will do local checks. Otherwise, we're restricted to only doing network checks. So at this point, I can select the template that I want to use, and we're going to do a full audit without a web spider. Actually, let me select full audit. So we're going to do a web spider as well. And then just kind of clicking through here, I have to select the local scan engine because this is on my local network. I can't use the hosted scan engine because it wouldn't be able to get to my local network. I'm going to leave alerts alone. Now I can just do save, and I could do a schedule if I wanted to run this later, for example. Or if I just want to keep this and run it later, I can just click save. In this case, I'm going to say save and scan. This is going to save this site configuration for me, and then it's going to kick off a scan using this site configuration. So it's going to use the assets that I added, so the one host, and it's also going to use the credentials that I added. So at this point, we're at a page that's just going to keep updating as the scan goes on. So you'll see that the elapsed scan time is increasing. So far, it hasn't discovered an asset yet. It's just getting started. This will run for a while as it goes and runs through a number of checks. And once we're done, we'll be able to look at the results and be able to generate some reports using those results. And we'll do that coming up. So we've got a completed scan now, and we can take a look at the results. We've got our dashboard here, and I'm just going to scroll down, and you can see the sites. And if I just click on one of these sites, I'm going to get the site scan summary. We've got one active asset, and it found 322 vulnerabilities. That's not a big surprise because the target for the scan was Metasploitable, which is a highly vulnerable Linux distribution. It's designed specifically to be used for training with penetration testing and Metasploit in particular. So if I click on the last scanned, what I'm going to do is I'm going to get the scan results. So I've got my completed assets, and you can see that it completed. And if I click on the completed assets, you can see that I've got Ubuntu Linux 8.0.4. We've got a name for it. And if I click on the IP address, what I'll get back is the list of vulnerabilities that we actually had. I've got my list of vulnerabilities showing 1 to 10 of 322, and let me just bump this up to 100 so we can see more of them. Now, I've got all of these things, and I've just got this list here, but let's say that I actually want to take a look at what each one of these is. Well, I can just click on this, and I've got some additional detail. So it tells me that there was a VNC service running, and it looks like we were able to authenticate to the VNC service. Now, the thing about Nexpose and any other vulnerability scanner is that what happens is it tests the vulnerabilities. It doesn't actually try to exploit them. In this case, though, we've got a service, VNC, that is prone to having a default password in place. And so, in order to test that vulnerability, Nexpose is actually trying to log into the VNC service. So there's no exploit there in that case. It's just attempting to do what the service is meant to do, which is log into it. But what we're doing is we're verifying that the vulnerability is real. That's not always the case, of course. What we've got is a very long list of vulnerabilities, and many of them have critical severities, as you can see. Now, these are old enough that there's a pretty good chance that these are actually real vulnerabilities. Just because a vulnerability scanner says there's a vulnerability does not necessarily mean there is a vulnerability. So, PHP, for example, what Nexpose and other vulnerability scanners are going to do, they are going to communicate with the web service in order to get a banner back. In this case, we determined that what we've got is PHP 5.2.4-2 Ubuntu 5.10. So that's a very specific version number. Because of this CVE here, it has a list of versions that are vulnerable. So we've got very specific information. Now, let's just say, for example, that all we were able to get back is the first part here, PHP 5. Well, Nexpose may actually make an educated guess, and it may not be this particular vulnerability, but there may be other vulnerabilities that says you may be susceptible to these. So the vulnerability scanner actually does the best job that it can with the information that it has. That doesn't always mean that you are guaranteed to have that vulnerability or even that the vulnerability is exploitable. It's just telling you that there is a potential that you've got a vulnerability on your system. And this is where it's really helpful to have somebody who's knowledgeable to be able to go through these sometimes very long lists in order to determine whether we actually have a vulnerability or whether we don't, in order to determine whether the vulnerability should be remediated. Now, this is just a really long list of vulnerabilities. You can also generate reports using Nexpose, and we'll take a look at generating a report and exporting that report coming up. We've got our list of vulnerabilities here, and you could certainly go through and click on every one of these to get more details. It may be more useful, though, to generate a report. And so we're going to generate a report here. And once we have generated the report, we can actually export it to a format that is useful. In order to create a report, I'm going to click New. I could do an audit report, an executive overview, newly discovered assets. If I wanted to see all of the potential reports that we could generate, we could say top 10 assets by vulnerabilities, top remediations. So let's do a top remediations with detail. And then we're going to generate a PDF. So I need to select my scan. and I'm going to use the one that we just completed. And even though we got the site, we need to have the specific scan. So every site may have multiple scans. So we've got to click through those different things. I'm going to say home report just to give it a name. And then I can save and run the report. Saving the report would be saving the configuration that we just generated. What I want to do is I actually want to run the report so that we get the PDF back so that we can take a look at it. So you can see that it's pulling all of the data together and it is generating a PDF for us that we're going to be able to look at. Now, you can see with Nexpose, there are a lot of capabilities, and it's really easy to generate reports. The most important thing about this is to be able to understand what's going on here. So that takes some time and some work and working with systems and doing a number of scans and looking at them and looking at the system to determine whether you've got an actual vulnerability or not, or whether it's what we call a false positive, meaning it's gotten flagged as a positive, meaning that there's a vulnerability there, but there isn't really a vulnerability. So there's a false positive. We've got a report that's generating, and let me just pop up a different report. And this one is HTML. So I did an HTML report at one point. And again, we're going to get the certificate error, and I'm going to say continue to this web page. And what I end up with is the XML from the report, which is good for importing into other tools. For example, Metasploit can take this XML report and import it so that you can populate the Metasploit database with all of the vulnerabilities that Nexpose has found. So you can see how long that report generation can take, and we do have a number of report output capabilities. So I could do PDF, I can do XML, and that gives you a lot of room to be able to generate multiple reports in multiple formats, and the different reports will have more detail about the vulnerabilities, and you should be able to use those to better understand what's going on the systems that you've been scanning. We're going to take a look now at Nessus, which is another vulnerability scanner. This one is created by a company called Tenable Security. You can download a personal version of Nessus and get a personal license so that, again, much like the community edition of Nexpose, you're going to be able to make use of it as you are learning how to use it and playing around with vulnerabilities and so forth on your local network. It is not for use in a commercial capacity. I'm going to go to localhost 8834, and that's HTTPS. And that's going to, again, present me with a certificate error. And I'm just going to say continue. I can log in. Again, just like Nexpose, this is a user I created when I installed Nessus. At this point, we have got a very simple interface, which is a little bit different than Nexpose. So with Nexpose, we had this big dashboard. Of course, with Nexpose, I had done a scan, but this is a very simple interface. And you can see that we've got a scans tab here, and we've got a policies tab as well. So in this case, I don't have any scans, so there's nothing on the scans tab. And I haven't created any policies either, so there's nothing there. We're going to take a look at creating some scans, which is going to require the creation of policies as well. The policy really dictates how the scan takes place. Are we going to do just network scanning? Are we going to look at web? We're going to look at whatever it is we're going to look at. That's what the policy is going to take a look at for us. So we've logged into Nessus, and the first thing that we want to do is we want to create a new scan. So that's very simple. All we do is click the button right here that says New Scan. And now we are going to walk through creating the scan, and we get a choice of templates. And this is actually where we determine what it is that we are going to be looking at. I really probably want to do an advanced scan so that we can do a complete configuration, but you can see the number of pre-canned templates that are in place. So if you wanted to look for shell shock, for example, if you wanted to look for malware or do policy compliance, you could select any of those. I'm going to do an advanced scan, and we're going to walk through the creation of all of the settings that are necessary to do an advanced scan. I'm going to name it a scan of home systems. I'm going to store it into the folder My Scans. So my target is going to be 192.168.86.66. Now I can go to schedule, and I'm not going to enable a schedule. Going to not enable notifications, although I could if I were to configure an SMTP server, and I could do that in the configuration settings. I don't want any email notifications. I'm going to say that I want to ping the remote host. That's going to determine whether it is up or not. Now we've got a variety of ping methods. I could enable or disable these. You don't have network printers. You don't have any Novell NetWare hosts. And so all of that is going to be okay. For port scanning, we're going to say consider unscanned ports as closed and just allow the default port scan range. We're going to use a SYN scan. We're not actually going to do a UDP scan in this particular case. As you can see, it says it's generally not possible for a port scanner to tell the difference between an open and filtered UDP port, so that you may have a much longer scan time and get unreliable results. And so we could say netstat or SNMP port enumeration options instead, if that's possible. So we are going to do SNMP here. Going to go to service discovery, probe all ports to find services. That works for me. And then the assessment, we're going to just allow it to do whatever it's going to do by default. So the accuracy is going to be whatever the normal accuracy is. And we could override that and say, don't show any potential false alarms or show potential false alarms. In this case, I just want to leave that alone. I am going to perform thorough tests, though, and I'm going to use credentials provided by the user. I'm not going to scan web applications here. I don't have a Windows host, and I'm not going to use malware settings. The report, the default settings are going to be okay with me. And then I'm just going to say save. And when it gives a list of scans here, I'm going to click on that and then just say launch. At this point, we have created a custom scan, and we are just running this. And this is going to take a while to run. We'll take a look at the results a little bit later on, but we're going to allow this to run. Again, you've got a variety of templates that you can use to create scans from, and you could just do an advanced as we did and really create the settings that specifically you want to look at. So we're going to let this run, and we'll come back and take a look at the results and reporting when we come back. So at this point, we've got a completed scan. Under My Scans, you can see that it shows up right here. And if I click on it, I've got the list of vulnerabilities that are broken out by categories. So I've got 7 critical vulnerabilities, 4 high vulnerabilities, 22 medium, 7 low, and then there are 112 just informational vulnerabilities. So if I click on this, I can drill into this a little bit deeper, and I got my list of vulnerabilities now. These are categorized in order of severity. The criticals are at the very top, and then the informationals are at the very bottom. I can reorder these so the informationals are at the very top, but you probably want to really look at the criticals first, and we can click on any of these. You'll get a description and then some additional information if you want to click one of these links that will pop open another tab for me. And in this case, this just happens to be a mailing list post that announces the advisory for this particular vulnerability. So this is a Debian security advisory. That provides a little bit additional information. This is related to port 22 TCP, which is SSH. So I can hop back over to vulnerabilities. I can keep clicking through here. I've got a description, and in some cases, I've got a solution. So in this case, the solution is to upgrade to a version of the Unix operating system that is currently supported. What Nessus believes is it found a version of, in this case, Linux, that is no longer supported. You can see that Ubuntu 8.04 support ended in 2011. Nessus considers this a pretty critical vulnerability, one of the reasons being that there are just no more updates for an operating system that is no longer supported, and that's a pretty significant issue. Sometimes you'll actually get solutions. In this case, it says comment out the login line in etc inetd.conf and then just restart the inetd process. This is really the important part. So finding the vulnerabilities, particularly with a vulnerability scanner, is really easy. Determining how to remediate the vulnerability, in other words, how to get rid of that vulnerability or at least mitigate it to minimize the potential for that vulnerability being triggered and something bad happening, that's really the harder part, which is where something like Nessus or Nexpose or any of the others that provide solutions are really beneficial. Many of them are just going to say update, because the fix is in the new package where there was a software bug that got addressed. So you can go through all of these vulnerabilities and read more about them and also determine what the solution is so that either you or the person you are working for or with in order to do the scanning can go remediate the vulnerabilities and go fix them so they don't exist anymore. Nessus, again, is a great vulnerability scanner. We've got a long list of vulnerabilities that you can go through. We can also export a report from Nessus, and we'll show you how to do that and why that's useful, and we'll do that coming up. Now, again, we've got our list of vulnerabilities in Nessus, and I want to export these results out to a report of some sort. So I'm going to click on export, and you can see, just as in the case of Nexpose, we've got a few options here. The first one you'll see is Nessus. What this particular option is going to do is it's going to generate a little package that is in a format that can be imported into other tools. So for example, if I were to export this, I could import it into Metasploit, and it will take the Nessus format in order to determine vulnerabilities and just populate the internal Metasploit database with the vulnerabilities that are found so that we can search for them inside Metasploit and make use of them there. PDF is pretty straightforward. So we can generate a PDF. Again, I've got some options here. So I could do just an executive summary, or I could do custom. So with custom, what do I want to include? Well, I probably want to include remediations, certainly. Do I want to include vulnerabilities? If I want to include vulnerabilities, do I want to do it by host or by plugin? Since in this case I only have one host, I'm going to do it by plugin. Nessus is now going to generate the report, and it is going to provide me with that PDF that I can view. What I'm going to get is a fairly detailed report with all of the vulnerabilities, and we've got 104 of them here. I can open it up, and you can see the report that we end up getting. I can scroll down, get to the table of contents. It's got the vulnerabilities by plugin, and I should just be able to click on any of these, and it will hop me straight to the output. So this looks an awful lot like what we had here in the list of vulnerabilities, where if I click on it, I get the description, the solution, see also, and then the output, and you'll see that I get basically the same thing. I also get a CVSS base score, and I've got plugin information as well. So this is the plugin that was used, and we've got the dates that are associated with it. There are a large number of pages in this report. So if I scroll all the way down to the bottom, you'll see it's 127 pages for the report, because every vulnerability has at least one page associated with it, and we had more than 100 vulnerabilities. So we get a lot of detail, and you've got it all in one PDF. So you could certainly present this to somebody and say, here's the results of the scan. That's not necessarily very useful. What you probably want to do is read through the report yourself, identify the issues that you think are really important before you present it to somebody rather than just saying, here's the scan report, because frankly, what value are you adding if that's what you're doing? It's really easy to trigger off a scan using Nessus. The value comes in doing the interpretation and working with them to make sure that they understand what the output says and how they can make use of that output to go about fixing the hosts in their enterprise systems so that they can be a little bit more secure and a little less open or exposed to vulnerability. We're back to Kali Linux now. And we're going to take a look at another vulnerability scanner called OpenVAS. OpenVAS is actually a fork of Nessus. Several years ago, shortly after Nessus took their product that was originally open source and made it commercial, OpenVAS started up and took the original source code from Nessus and used that to create what became OpenVAS. This is something that you can install for Kali Linux. Based on the number of packages here, you can see that there's really a lot that goes into OpenVAS. So in order to get started, I have installed OpenVAS, and so the very first thing I need to do is do OpenVAS setup. Now, this is going to create some certificates and then walk through downloading a lot of files that it needs to get started, including the base signatures that it uses to determine whether there are vulnerabilities or not. It's going to go through this for a while. You can see that it's going to take a couple of minutes here just to download this file. And then there's some other work that it does. Once it has done that, it will go and do some database work. And eventually it will create the admin user, and it will generate a long passphrase for you that is alphanumeric. So it's not based in any sort of words, it's a series of characters. So it's truly random. So it's not the kind of thing that somebody's going to just randomly break into and guess the password. Once you have gotten through the setup here and all of the database work and all of the files that need to be downloaded have been downloaded, then we can start the services. So OpenVAS-start will start all of the necessary services that OpenVAS uses. There are some underlying services, including the OpenVAS manager, as well as there's a scan daemon as well. This is similar to the engine that we were looking at with Nexpose. There are some underlying services with OpenVAS that are necessary to be installed. Once we have done all of that, we can connect to the OpenVAS web interface. Just like Nessus and Nexpose, there is a web interface, which is how we get into doing scans using OpenVAS. Now, previously, there was a native client that you could use, but they have moved off to just using a web interface. Makes it easier to get access to. They don't have to worry about spending development time on this client. They just create the web interface. Everybody's got a browser of some sort or another. Once you have gotten OpenVAS installed, you run OpenVAS-setup, just as we are doing here, and all of the configuration work gets done for you. And then once everything is done, you make sure that the services are started, and you can do that by just typing OpenVAS-start. And once that is done, then we can get into the web interface and we can start running scans. OpenVAS is set up. I'm going to fire up Firefox. And in order to get to OpenVAS, we go to HTTPS and localhost :9392. And just as in the other cases we've got a self-signed certificate, and so I'm going to confirm a security exception, and the username is going to be admin, and I'm going to paste in the password that I was provided. Now we've got the Greenbone Security Assistant. You can see here that we can do this very easily, and this may be the best way to just get started. You could go into scan management and start a task and create a scan that way. You can create hosts in asset management, and of course, you can go into configuration. But the easiest thing to do is just to plug an IP address in. So we're going to say 192.168.86.68. Now I can just say start scan. That's just a very fast way of getting started with a scan. So you can see right here underneath there, what it says is it's going to create a new target with a default port list, create a new task using this target with default scan configuration, and start the scan task right away. So we could do essentially the same thing. We're actually on the tasks view here, and we could go to a task wizard and we could walk through the task wizard to be able to create a scan. We could build scans to do a number of different things that we want to do. So it's similar in the sense that it's a vulnerability scanner, and there are a number of different ways of doing scans. The challenge with OpenVAS is it's a less intuitive interface than the other ones that we have looked at. There's a lot of text here, and you can look through this, but there's nothing immediately, as you can see, that says, oh, by the way, we're just going to create a new scan, or we're going to add assets, or the other approaches that we had previously used with Nexpose and Nessus, for example. So you can certainly go through and do a new task here, for example, and we could create the scan and say, my house, add a comment. We could add a target that has previously been configured. At this point, we've got localhost and the target that I had provided before. I could add a schedule, and I could add the results to asset management, and then delete or not delete reports, and so forth. I could create a task, and then once we've got the task, we could start the task to create the scan. But as I said, one of the advantages of using OpenVAS is it's just got this quick start to be able to go and run scans from. Now that we've got a completed OpenVAS scan, we can look at the results. You can see from the status here that we are done. I can go to the current report just by clicking there. And what I get here is a list that's very similar to the others, other than what I've got is a filter here that I can change. And so I could manipulate this filter if I wanted to in order to change what I actually get here. So for example, I could easily say 150 and then just refresh that. So I could manipulate the others. I'm just going to leave those alone. I really just want to skim through and look at the vulnerabilities so that we can see what we get from OpenVAS if we were to just select one of them. So for example, I'm going to select here, and similarly to the other two, we get a summary here, and then an explanation regarding the vulnerability detection, and then we get the method. So in this case, they are using the plugin OS end of life detection. So I can go back to my list now, and you'll see that there are little icons here under the solution type. So in the first one, there's really no solution. The solution is just get up to date on the latest one. So if we were to go to XSS here, this is TWiki, and there is a cross-site scripting apparently. The solution here is a vendor fix, which is upgrade to version 4.2.4. So this is a useful column, and we've got a separate one here, which is a workaround. So you can see the icons represent the type of fix that is in place. So if we were to click on this, what we would get would be a solution that's really a workaround rather than a fix, which says disable class loading. So it's useful to have these little icons to indicate what type of remediation that is possible here. In this case, it's a mitigation, and we've got a vendor fix on that one. So we've got remediation, we've got vendor fix, and then we've got workaround, and we've got a pretty extensive list of vulnerabilities. I could add actions here. For example, I could add a note if I wanted to, which provides me some additional context potentially of, say, we are not going to fix this one. And then I could create a note, and now I have attached a note to that particular vulnerability, and you can see that we get a little icon there, and it says notes. So if I were to click on it, I would get a note that says we're not going to fix this one. This ends up being more of a vulnerability management solution in some regards than just simply a vulnerability scan tool, because we have the ability to really manage the vulnerabilities by adding notes so that we can keep track of what we have done and what we are going to do. But in terms of the results, generally it's pretty similar to the others, where we get just a list of the vulnerabilities. This is different where you've got a classification for the solution type, so you can see pretty clearly ones that you were able to do something about in a particular way. So, for example, vendor fix. In this case, the solution is just change the password. There isn't a vendor fix, there's not a workaround, there's just a flat out go fix this. We've got another one here that doesn't have an icon, but the solution is that there are some vendor updates. So go and check out the vendor updates where you can go update the package that has been installed here. So we have our list of vulnerabilities in OpenVAS. And again, you probably want to do an export of them so that you've got a copy somewhere. Either you want to copy and paste things out of it, for example, to create your own report. You want to just hand it over wholesale. Maybe you want to do some importing into another tool. From the list of vulnerabilities here, we've got a pull down for the format of the report. There are many more options here than we have had in the other tools. There's anonymous XML. We've got comma separated values of hosts and of results. We can do HTML. We can do LaTeX. We can do PDF. And let's just select PDF. That was the default after all. So we're going to generate a report. And I'm just going to open it up so that we can see what we get for a report. And this looks very similar to some of the other ones that we have looked at. Because of the tool that we have opened this up in, we've got a little outline view on the left-hand side, and I can just click through here and we can see the results. So I've got a high vulnerability here, which is a remote method invocation server for Java. And it starts here and says continues on the next page. And sure enough, we've got the next page here where we've got a workaround, and it says disable class loading. There are details here around how the vulnerability was detected. And there are a number of vulnerabilities, and we've got a pretty long report. This isn't quite as long as one that we had looked at previously. This is 109 pages long, but considering the number of vulnerabilities that we've got, that actually is not an unreasonable number of pages to have. We do have a lot of vulnerabilities on this particular host. As I said earlier, this is a system that is designed specifically with a lot of vulnerabilities in it for this very kind of work. So getting a copy of Metasploitable is a great idea. I'm using Metasploitable 2. Metasploitable 3 is out. It's different than Metasploitable 2, and I still like using Metasploitable 2, even though Metasploitable 3 is available. It's a very different installation approach. Metasploitable is just an appliance that you download, open it up in VMware or whatever your preferred hypervisor is, where with Metasploitable 3, you have to build the entire image, and currently it only runs inside of VirtualBox. So that's a couple of reasons why I haven't migrated over to Metasploitable 3 at this point. It's not quite at a fully baked stage, but it is available if you want to play around with it and you've got a copy of VirtualBox and a system that you want to install Metasploitable 3.2. OpenVAS, as I mentioned, is another vulnerability scan tool. It has similar capabilities to the other ones that we looked at. One of the advantages to OpenVAS is that it is entirely free. It is something that you don't have to go through any licensing for. You don't have to limit yourself to the type of work that you do with it, where you would with the Nessus Home or the Nexpose Community Edition, where it's a limited implementation, so you can only do 32 hosts, and it doesn't have the capabilities of the versions of Nexpose that you pay for. So this one is entirely free. It may not be as pretty or user-friendly as the others, but as I said, it doesn't cost anything. It comes with Kali. If you're using Kali Linux as your primary operating system for doing this kind of work, then certainly you can make use of OpenVAS, if nothing else, than to just get started on playing around with doing vulnerability scanning. We're going to get a look at the exploit database. This is a website that you can go to take a look at the exploits that are available. So these are proof of concepts or other types of exploit code that somebody has created, and it may actually be really useful for you as you are doing penetration testing work, because you should be able to go in and see whether there are exploits that may be available for the piece of software, the operating system that you are working on. Exploit-db.com is where the exploits that are just provided for free by a variety of people who work on this sort of thing. And there's also the Google hacking database that is stored at this website. If we were to just click on one of these, for example, you would see this is actually the exploit. So somebody wrote a Python script, and you could download this and you could run it if you were looking to take advantage of this particular CUPS vulnerability for version 2.0.3 or less. So for versions less than 2.0.3, there is a CVE that's associated with it if you want to read up on that. And we've got an author as well. There is a vulnerable application, and that's the Common Unix Printing System, or CUPS, and there's the Python script. Sometimes there will be source code that's written in C, sometimes it'll be in Python, sometimes there will be something else maybe that is available to you. In this case, here is some HTML that could be used to exploit this particular vulnerability. You're going to get a variety of types of content that you're going to be able to use from the exploit database, but there are a large number of exploits that are available to you, and it's a pretty good resource to just keep in the back of your mind, or maybe bookmark it if you use bookmarks. So I'm at the exploit database again, and I just want to talk about different types of exploits. There are a number of types of exploits. We've got vulnerabilities that we had talked about before, which are weaknesses in either software or configuration, and exploits trigger those vulnerabilities to do something bad, whether it's getting you access to a system or triggering a denial of service or something else. So we've got different categories of exploits that are available at the exploit database. Remote exploits are things that you would throw at another system across the network. You are remote from that system when you trigger the vulnerability and use your exploit. Now, we've also got web application exploits. These are also remote, typically, in that you would be gaining access to a web server where the application lives, but they are targeted very specifically at web applications. Whether it's PHP or Java or .NET or whatever the application is written in, you are using web technologies over HTTP, and maybe you're doing Ajax or something like that to get access to this web application and exploit it. There are also local and privilege escalation exploits. If you are logged into the system, you are doing a local exploit. If you don't have administrative privileges and you want to get administrative privileges, you need to do a privilege escalation. So you are escalating the level of privileges that you have on the system that you are on. Now, in order to do a privilege escalation, you already have to be logged in. This isn't something that you can do remotely, other than you could do a remote exploit, get into an unprivileged user account, and then trigger a privilege escalation. There are also denial of service attacks. So a denial of service is anything that's going to make a service unavailable to another user. If you can crash the service and take it offline, you have just done a denial of service, because it means nobody else can get to that application anymore because it's down. There are shellcode archives here as well. Shellcode is binary code that is used to actually plug into memory so that you can alter the way that the program works. And it's called shellcode typically because you're going to pop open a shell. So you can see this one is going to execute bin sh, and that is going to get you a shell on a Linux system. So also here, they've got archived security papers that may be useful to you. Those are not exploits, but this is a pretty comprehensive site in terms of what it provides to people who are doing security testing work. Exploit Database is a great site. We've talked about it before. And you can see that they've got categories of exploits that are available. So keep in mind, they're remote exploits, web application exploits, local and privilege escalation exploits, and then denial of service exploits. And they've kind of lumped in proof of concept exploits as well. Let's talk about Metasploit. Metasploit is an exploitation framework. The exploitation framework is a place where you can very quickly and easily, if you know what you're doing, develop an exploit that could be used against a vulnerable piece of software. The framework includes a number of building blocks that you can cobble together along with whatever glue you need in order to make the exploit work. And you can create an exploit, as I said, very quickly, rather than having to create everything from scratch, including maybe developing shellcode. There are shellcode modules that are in Metasploit. The other thing that Metasploit does, even though it's an exploit framework, it also has a number of modules that are just plain exploits. So you can use Metasploit to trigger vulnerabilities by using exploit modules. I am at Metasploit.com. This is a piece of software that's developed by a company called Rapid7. You could go to Rapid7 as well. I just happen to have gone to Metasploit, and you can acquire Metasploit. It is a free download. There's a community edition and there's a pro version. The community edition, as you can see, is limited features, and it's great for just learning. And you can see the differences here in what you can do. You can import, you can do network discovery. With Pro, there are meta modules for doing network segmentation testing, for example. You can also do a remote API integration. You can do automation with the Pro version that you can't with the community version. You can do a number of things with phishing awareness management and spear phishing and doing web app testing for the OWASP top 10 vulnerabilities. So there are advantages if you are actually doing this to getting the pay for versions of Metasploit, but certainly there is a community edition, and there's also just the framework, which doesn't include some other capabilities. For example, the web interface is not included with just the framework where it is with the community version. So we're going to dig into Metasploit and start using it to do various things with running exploits and importing data and doing a number of other things that Metasploit is capable of doing. Now that you know what Metasploit is, let's actually take a look at it. Let's say that you've got a Kali instance or a virtual machine or even a real hardware implementation of Kali. You've never run Metasploit before. The first thing that you need to do is you need to initialize the database. So msfdb init. Mine is already configured, so it's not actually going to initialize it. But if you have never run Metasploit before, you need to run msfdb init. You can run without the database, but there are going to be some things that are more challenging. For example, searching is going to be quite a bit slower. I'm going to run Msfconsole. This is going to bring up an interface into Metasploit. You're sitting here at an MSF prompt and you're saying, wow, there's a lot of exploits there. Look at the auxiliaries and the payloads, the encoders. Oh my gosh, there's so much here. What can I do? You can use help. There are a number of commands. You can see all of them here. There are a handful that you're going to use more regularly than others. And one of them is going to be show. You're going to use show probably a fair amount. As an example, we can say show exploits. And since there are over 1,500 of them, it takes a little while to compile the entire list in order to show it to you. Once the whole list is prepared, you'll see that it pops up pretty quickly. You won't even see the list actually scroll by. It will just kind of suddenly appear at the end of the list. But there are over 1,500 of them, and you can see suddenly there's our list, and I can scroll backwards through it. There are a large number of them running kind of the gamut of operating systems and applications, and just a large number of exploits that are available. And of course, I can also show the payloads that are available. There are other applications of the command show. We'll get into those a little bit later on when we start working with exploits in more detail. But just keep in mind, if you ever get stuck in Metasploit, you can always say help. And I can also, for example, say help show or help any of the other commands, and it will provide you with a little bit of help to remind you of how the command actually works. So another one I want to show you really quickly is there are some database backend commands. For example, we can check the status of the database. You can see that we are connected. And there are a number of other ones. Some of them we're going to be using a little bit later on as we do some additional work in Metasploit. Metasploit used to come with a utility called Msfcli, which was a way to pass in a series of commands into the Metasploit framework. There is a way to do that, and I'm going to sort of refer to it as the CLI to avoid confusion with the console interface, which we had looked at previously, but really it's just using Msfconsole, and then you can say -x and then the series of commands. So we're going to use exploit Windows SMB MS08067 net API. And then between the commands, we use a semicolon. Then I'm going to set my R host to be 192.168.86.69. And then we can say set payload to be Windows Meterpreter reverse TCP. And then we can just run it. I should be able to just do this, and it's going to start up the console, and then it's just going to start running the command. You can see we set the R host, and what I missed here was to set the local host. So I needed to set the IP address for my local host. If I had done that, then we would have been able to run this exploit. But you can see that it very quietly does everything in the background. And then eventually you end up with a shell into the remote system. Now, there's another way of doing that. I could use a resource script. I've got script.rc here. What I should do here is to set my local host. And that is going to be based on what my local IP address is. And so that's going to be .22. So if I go in here to my resource script and say set lhost 192.168.86.22, now what I can do is say Msfconsole -r, and then we can give it the name of the script. And now it's going to do basically the same thing that it had done before with the -x. And you can see that we are using and setting the various things. And now I have a Meterpreter shell on the remote system. You can script up your interactions with Metasploit and then just run them, whether you're doing it directly on the command line in a string of commands using -x, or whether you're using -r and you've got a file with your set of commands in it. Either one works just as well as going into Msfconsole and just typing in the commands as you're there. So we want to talk about importing data into Metasploit. And I have mentioned previously that you can take report data from a vulnerability scanner and import it into Metasploit. I've got a report here that I had exported into NBE format from OpenVAS. So I'm going to fire up the console here, and then we're going to import it. And we do that using the command db import, because what we're doing is we are importing into the database. I'm going to say report.nbe, and we've imported the host, all of the vulnerabilities that were in that particular file. I've got a fair number here, and you can see how easy that actually was. All you have to do is have something that has been stored in Nessus format, and OpenVAS and certainly Nessus will do this, and you can import the results into Metasploit. You can also take in input from Nmap if you have stored it in one of the output formats that Metasploit can handle. So, for example, XML. But you can also, which is much easier, just do the scanning from inside Metasploit. And we'll take a look at doing scanning from inside Metasploit and just directly populating the database. We'll take a look at that a little bit later on. But you can see how easy taking vulnerability scans and just importing them into Metasploit actually is. And then once they are in Metasploit, you can take a look at all of the vulnerabilities in the hosts that Metasploit knows about. And we'll take a look at how you would go about doing that coming up next. But just keep in mind that if you want to do an import, all you have to do is db_import and then specify the file. In this case, I specified the entire path to the file to make sure that Metasploit would be able to find it. If you specify the path, you don't have to worry about what directory you happen to be in when you were running Msfconsole. And in this case, it's a short path anyway. It's just easy to do. db import and then the file name, and you will get all of the results in Metasploit that you can then look at without having to hop out to another interface. So now that we have our data imported into Metasploit, we can take a look at what Metasploit has actually stored for us, and we're going to use some database commands. The first thing that we're going to do is we are going to look at all of the hosts that are in the database. If I type hosts, I get a list of the 2 hosts that I had actually done a scan on. Had I scanned an entire network using OpenVAS and then exported that, I would have gotten quite a bit more, and we'll certainly see more hosts as we do some additional scanning using Metasploit later on. One thing that I want to show you really quickly, because we haven't talked about it before, is I can do tab completion inside Msfconsole. So if I type HO tab, Msfconsole just completes it for me. Now, we don't have to be limited to just typing hosts. We could, for example, type hosts -s Windows, and what I get then is just the Windows hosts. I could say hosts -s Linux, and I won't get anything back because I don't have any Linux hosts that Metasploit is aware of in there. I can also limit what I am doing with hosts. I can specify I only want the columns address and OS flavor, and then I could say Windows. And in this case, I just get the address and the OS flavor. So you can specify the columns, which are these right here, and limit the amount of data that you get back. That's how we would look for hosts. I can also take a look at the vulnerabilities that are listed. So if I just type vulns, I'm going to get the entire list of vulnerabilities that have been imported here. Now, I can also do some additional searching within the vulnerabilities. So I could, for example, say vulns and then -p, and I'm going to say 80. There's nothing that is associated with port 80 that has been triggered in my vulnerabilities. So I can just look for additional port numbers and see whether we have something that has been associated with a particular port number. I could also do a search for a particular string. And so let's say -s, and I'm going to search for Windows. So I get a couple of results back. Now, something else that I can do using the database is I can look for services. Now, we don't have any services that have been identified here, partly because we haven't done any service scans. But this is something that you can query the database for, is to get a list of the services. So you'd get the host and the port, and then the protocol that was listening on that port, as well as the name. And we can certainly populate that a little bit later on as we do some scanning within Metasploit. We're going to take a look at how to search within Metasploit, and this is going to be really important because you're probably not going to always remember the specific module or exploit that you want to use, and so you're going to want to be able to search. Now, I could just search, for example, for a particular keyword, and I've got a number of results back. But I could go a little bit deeper there, and if I say help search, I get a number of keywords that I can really drill down using. So I could say search CVE in, let's say, 2015, and then type is going to be exploit. I've got a number of results back here. So there are CVEs with the number 2015 in it. I've got the results where they are exploits. I can search for author names if you know of a particular author. If you happen to know of a bug track ID, that would work. You can search for particular platforms. I could search for Windows, for example, and I could look for exploits that were available for Windows. Or I could say search type exploit and then platform, let's say, is Linux. I've got a number of results back that match that. So I've got things that match Linux and that are type exploit. I can use the search command to really get some additional details, and you can help narrow the field down rather than just saying search, for example, Linux and getting a whole lot of results back. You can narrow the field down a little bit, looking for particular applications and so forth. So searching is going to be really important to you so that you can find the particular modules and exploits and scanners and so forth that you're going to want to be able to use, because there are thousands of them here within Msfconsole, and that's just today. There are ones being added constantly. So using the search function is going to be something that you do on a very regular basis. And we're going to do some of that coming up as we start looking for particular exploits and doing some scans. We're going to take a look at scanning within Metasploit. We've done Nmap scanning before, and you've seen the Msfconsole. we're really going to kind of marry those together. And also, I'm going to show you some other kinds of scanning that we could do with Metasploit. The first thing I want to do is I'm going to just bring up the help again so we can see the various database things. You can see that there's db-nmap. db-nmap is a way of running Nmap from within Msfconsole, and it runs just the same as Nmap does on the command line, because really what it's doing is it's just calling Nmap. I can do a SYN scan and a version scan, which is going to give me services. I'm going to run that on my entire network here. What I should end up with at the end is a number of hosts that are not currently in the database, as well as the services that we were not able to pull up before. And we should get those by running Nmap and doing the version scan. The great thing about this, as I said, is not only do you just kind of collapse two processes into one by doing this inside Metasploit and populating the database, but you populate the database. So you could run Nmap, export it to an XML file, for example. So you set the output and then import it into Metasploit and populate the database that way. Or you could do it this way, just run it right inside Msfconsole and you get the results from Nmap, but at the same time, you populate the Metasploit database. So you've got the services right here, and you know which services that you may want to target and be able to identify potential vulnerabilities more easily. You could do Nmap and just populate that way. Or another thing that you can do, and I'm going to kill this because it's going to take a while, is you could use, and there are a number of scanners that are available within Metasploit, and one of them is the SYN scanner. And I'm just going to show options as I would typically do here. And what I need to do is set our hosts, and I'm going to set that to my local network. And I'm using CIDR notation that says 24 bits of subnet mask. Now, all I need to do, since nothing else is particularly something that I feel I need to change, I can just say run. And now I'm going to get a port scan running using a module that is built into Metasploit. This is something that is in Metasploit itself. We're not calling Nmap in this way like we were with the db_nmap. We're just running this port scan module, and we should get a list of all of the ports that are open on the network as a result of that. So here's where the rubber actually meets the road. When it comes to doing penetration testing, we're actually going to break into a box. So we're going to get the Msfconsole running, and we're going to take a look at the services now that the Nmap scan has completed. And you can see we have quite a few of them. This is one that I happen to know has a pretty good vulnerability associated with it. So we can search distcc, and I'm going to use that exploit. Now I can hop back up here and just take a look at the IP address that was associated. And I'm going to copy that and then set my R host, because our host is a common parameter across exploits, because we need to know the remote host that we are going to be attacking. So let me just see what other options are available, and pretty much that's it. So I can just type exploit. Now I have a command shell. You can see that I have been dropped into the temp directory, and I can move around. What I'm not getting here is I'm not getting a prompt back because I didn't do any login. I just popped a shell back using this particular exploit. So I can move around the file system, and I can also figure out who I am. I am the name of the user that the distcc service is running as, and that happens to be Daemon in this case. And this is a user that doesn't have an awful lot of privileges. I'm limited to only the privileges I have with this particular user, which isn't going to be much. In order to do much of anything else, I would have to do some sort of privilege escalation in order to get super user or root privileges. And there are a number of ways of doing that. There are programs I could upload to this particular host and run those to get a privilege escalation. And there are some ways that we can do it using Metasploit, and I can show you how to do that coming up as well. Now, one of the advantages to using Metasploit is the number of payloads that are available. I'm going to start up Msfconsole again, and there is a particular exploit that I know works pretty well on one of the systems I've got here running as a virtual machine. It's a very, very old version of Windows. And so I'm going to search NetAPI. The one I am looking for is this one here. And so I'm going to copy that and then use it. And the first thing I need to do is set my R host, because that always needs to be set if we are doing remote exploits. So that's going to be my R host there. What I can do is I can set my payload, and the payload is the chunk of code that is going to be delivered to the remote system and executed. And it really determines the interaction that you are going to get with that remote system. What I can do here is set my payload, and I am going to set it to Windows shell reverse TCP. Before I actually do this, I need to set my L host, and my L host is going to be my local IP address. So that's going to be 192.168.86.22. I need my L host set so that the payload actually gets this IP address, so the remote host knows where to forward the message back to. And now I can just exploit. I've got a remote shell on that system. And so this is actually a command prompt, which is what the reverse shell, of course, would be. I would get a command prompt back, and you can see Microsoft Windows XP. It looks exactly like it would look on the local system if I were to open up the command prompt. And you can see the path that I am currently in, and I am in system 32. So I have remotely exploited a target system, and I have set a payload that gives me a Windows shell or a command prompt back. You can set different payloads. If I were to show payloads, you could see all of the payloads that were available. Not all payloads are going to be available for all exploits. It really depends on the exploit and how much space is available in the exploit, how big the payload actually is. And of course, it's also dependent upon the target platform. You can see a number of Windows payloads, but there are also Linux payloads, there are Android payloads, there are payloads for different platforms, and they can be used for different applications. You can set different payloads in order to get different behaviors back from the remote system. And some of that has to do with whether you're going through a firewall, whether you're NATed, all sorts of other different things. You can set the behavior of the interaction with that remote system by setting the payload. Another great advantage to Metasploit is this thing called Meterpreter. Meterpreter is entirely operating system agnostic, and it is a way to interact with operating systems in a very consistent way. So I can do things with Meterpreter, and it doesn't really matter what the operating system is on the other end. The Meterpreter shell handles the translation between what I am telling Meterpreter I want and how the operating system actually handles it. We're going to go back to using this particular exploit. And again, I'm going to set my R host to be 192.168.86.69. And my L host is going to be 192.168.86.22. And then I'm going to leave everything else alone. So I could say show options, and that's all okay. If I were to just say set, I would see everything that is available for me to set. I don't need to touch any of this, but you can actually see what the different values and parameters are. Now all I'm going to do is I'm just going to run exploit. and that should pop open a Meterpreter shell for me. And sure enough, I have a Meterpreter session open. Now, Meterpreter, I get a help list, and you can see all of the things that I can do here. I can do a number of things that are related to processes like background a process, kill a process. I can run things in the background. And I can also make use of file systems. So, for example, if I were to print the working directory, I could get that. I can also get the process identifier for the process that we compromised on this system, and the process ID here happens to be 1108. I can get the security identifier of the user, so get SID. I can also do the ARP cache. So those are the ARP entries in the ARP table on the remote system. I can also do things like get a screenshot. So I could capture a screenshot and that would be saved as a JPEG into my home directory here. There are a number of other things. If there were a microphone or a webcam, for example, I could try to take advantage of that. We're going to take a look at another database function. This is the function loot. What loot is information that we have gathered from the remote system. I'm going to use another exploit here. I'm going to use the Unreal IRCD exploit. This is a backdoor, meaning there's something in the code that has opened up a port that wasn't expected in this particular service, and that is allowing somebody to connect. So I'm going to use that and going to show my options again. So I need to set my R host to be 192.168.86.68 here. And then I'm just going to run the exploit. I should have a remote shell in just a moment. And sure enough, I've got a command shell open. I've been dumped into Etsy Unreal D. I'm going to background this session, which means it's going to stay running, but it's just running in the background. I'm going to use a post-exploitation module, and this is going to be gather hash dump. I'm going to show options. These are modules that you can run post-exploitation. And so if I say sessions minus L, I have 1. And so if I set session to be 1 and then I run, I should pull back the hashes. And sure enough, I have. And now all I have to do is say loot. This has all been stored in the database. I still have my shell open in the background, and I have run a post-exploitation module in order to acquire the hashes from the system that I have exploited. They have been stored locally now, and I can use these later on to do some password cracking with. You can acquire loot using these post-exploitation modules, and they will just automatically get stored in the database that Metasploit has. We can acquire the loot and it will just be there. I can quit out of this and I can drop the shell altogether. I will just have these hashes to be able to do whatever I want to with them later on. Now, let's say that you've got a target system and you've discovered that there are multiple interfaces on it. If there are multiple interfaces, that means that there are multiple networks. Where there are multiple networks, there are multiple systems. You can use a session that we get through Metasploit to be able to route through that remote system and gain access to those other networks. Let's talk about how we go about doing that. I'm going to pick on Metasploitable again, and I'm going to use a different exploit this time. I'm going to use a Tomcat exploit, and we're going to use Tomcat Manager Deploy, and I'm going to set my R host to be 192.168.86.68, and then I'm going to set my payload here to be Java Meterpreter, and then reverse TCP. Because we're getting in through a Java application server, we're going to use the Java Meterpreter, and the reverse TCP, as I've mentioned before, means we want the target system to fire a connection back to us. So we're going to say reverse TCP. Let's take a look at the options again. And I actually need to set the R port, and I also set the username and password here. Tomcat, in this case, is running on port 8180. And you could use the services to see that Tomcat is actually running on 8180. And I also happen to know that the username and password here are Tomcat. You could use a module that Metasploit has available, which will do a username and password attack on Tomcat to determine whether it's a commonly used username and password. But to save time, I happen to know what these are. And if you had a Metasploitable 2 system, this is what the username and password would be. So now all I need to do is set my L host to be 192.168.86.22. That's me. And I need that so that the payload can be fired back at me. And now all I need to do is say exploit. I've got my session open, and I'm going to just say ifconfig, and you can see that I've got multiple interfaces. So now all I need to do is say run autoroute, and I'm going to say -p to have it print out the routes. So I could say now run autoroute -s, and I'm going to say 172.30.42.0/24 is going to be the target network. And we're going to add that through 192.168.86.68. Now, I could also see whether there are other networks that may be available. So now if I look at the routing table, I've got the list of my routes that I have available. I could also run autoroute -p. I could get the routing table list. So 172.30.42.0 is going to run through session 1. In order to do what we call pivoting, you set routes to run through the sessions that you have open on your remote system. And then when you send traffic to that target network, it's going to get routed through that other network. That does require that the target system be able to forward packets from one interface to another, which isn't always the case. But you can change your local routing table to go through Meterpreter sessions. One way to do that is to use the autoroute module, and you do that by run autoroute. So let's assume that you are working with an enterprise and you're looking at a host of desktop systems or maybe even servers. And let's say that you are able to get a password dump, and you've been able to get into one of the systems and you've dumped the password hashes. Let's say that we were going to do something like Windows SMB, and I can set my R host and then set my L host to be 192.168.86.22. And then if I exploit, I should get a Meterpreter shell back. And then what I can do is run post Windows gather and then hash dump. And then I'm going to get the hashes dumped from the SAM, or the security account manager, and I should get a list of usernames and passwords. I'm just going to grab the hash from one of these users, and then I can exit out of this. And then I'm going to use that hash to authenticate. And let's say that you're targeting another system at this point. I'm going to use the same system because I don't have a large enterprise network. What I'm going to do, though, is use exploit Windows SMB PS exec. And I'm going to set my payload to be Windows Meterpreter reverse TCP. I can set my local host to be 192.168.86.22. I'm going to set my R host to be 192.168.86.69. Then I need to set my SMB user to be the user that we had grabbed the hash from. And then I can set the SMB password. In this case, I don't actually have to crack the password from this hash. I don't have to take the hash and then try to get the password from it. I can just use the hash. Now, this technique has largely been shut down by Microsoft, and it doesn't work all that well anymore on more modern operating systems, and we're going to have a problem with it here, and Metasploit will explain why we are going to have a problem with it. But the concept of pass the hash is generally considered an important one. So what we're doing is we are trying to authenticate to the server using file sharing protocols, and we pass in the username, and then we pass in the hash rather than the password. And since the password is generally going to be hashed anyway before it's sent, what we're doing is we're just sending the hash along, so we don't actually have to get the password from it. Typically, if you are doing this within an enterprise, as this says, I'm actually targeting a Windows XP system. It's something I've got that's just really easy to target. And the problem is that Windows XP systems that are not part of a domain are only going to provide guest privileges to network logins by default. Since I don't have a domain controller here that I could make this a part of, I can't actually send the payload along to get me a Meterpreter shell back on the system, but the concept still remains the same. You set the username, you set the password, you use psexec, and then the password, as I mentioned earlier, is going to just be the hash that you were able to get from another system. And then you can use psexec to target other systems using that username and password combination to try to get into other systems that you assume are going to have, for example, the same administrator username and password, because that's going to be common because all of the systems are going to be administered centrally. Passing the hash, as I mentioned, is a really important concept. And what you're really doing is you're just taking a password hash in the way that it is stored within the SAM in Windows, and you're using that hash to pass on to other systems with the assumption that the username and password are going to be the same from one system to another. In most cases, when you compromise a system, you're going to gain access as a user that has restricted or limited permissions. Keep in mind that when applications run, they always run within the context of a user, meaning there is a user that is running that application, even though it may not be an interactive user like you, for example, or me. There is a user to provide a security context, meaning a set of permissions. So when you compromise an application and gain access to it, as we've been doing here using Metasploit, you're going to gain access as the user that that application is running as, and you may, as I say, get limited permission. So what we need to do is we need to elevate or escalate our privileges so that we can do something useful on the system. Or at least if we were an attacker, that's what we would want to do. And so as security testers, we need to be able to do the same thing so that we can demonstrate where there are vulnerabilities. I'm going to show you a couple of different ways in order to do this. And we're going to get into Msfconsole again. So the very first thing we're going to do is we're going to take a look at the Windows system. And this is the Windows system that we had used before. And so I'm going to make use of the Net API again. So I need to set my R host again to 192.168.86.69. And then I'm going to set my L host to be 192.168.86.22. And then I am going to exploit the target, and I should get a Meterpreter shell back. And once I get the Meterpreter shell back, I can show you one way of doing this. Right here, you can see get system will attempt to elevate your privilege to that of the local system. In this particular case, I am actually the local system because that's the user that this particular service is running as. But we can certainly run get system. And this says we got system via technique number 1, which is named pipe impersonation. Another way of doing this is to use a second vulnerability. I'm going to make use of the distcc vulnerability that we had looked at before, and I'm going to use that to target the Linux system. So we're going to use that. Then what I need to do is I need to set my R host again to be 192.168.86.68. And then I'm going to set my L host to be 192.168.86.22. And then what I can do is I can just run exploit. Now I've got a command shell open. I need to grab the exploit that I have compiled already. What you may notice here is we're not getting any responses back from the operating system. It feels a little bit like we are doing this blind, but I can assure you that if we were to actually have a problem, we would get an error. And so if I don't get any response at all, I'm going to be okay, because it just means that it was acceptable. So I'm going to use this shell script. I forgot to redirect the output into the file that I need to put that into. So we just got the echo back. And I need to do the double greater than because I'm appending. If I were to just do a single greater than as I did the first time, I would be creating the file. So I'm going to append to /temp/run. And now what I need to do over here is in the second window, I need to listen for the reverse connection that's coming back. Because I didn't specify UDP, I'm listening for TCP connections on port 3377, which is the port that I said I was going to use there. There are a couple of ways to go about what I am about to do here. This is one way. I need to find the process ID for the udevd process. I am going to now say ./exp, which is going to be the exploit program that I had downloaded. And we're going to say 2686 because we're going to go one less than the process ID. And this is going to now exploit the udevd binary or the process that's running. And I need to make sure that it is executable first. And now I can say ./exp2686. And now I've got a connection here. And all I've got to do is say ID, and I can say uname, and you can see that we are in the Metasploitable system. So I've used this second exploit to exploit the vulnerability that's in the udev daemon. That calls the /temp/run script, and that fires a netcat session back over to my system here with a root shell. So you can see we've got a couple of different ways of doing privilege escalation. One of them being if you've got a Windows box, you can try to just get system. Another way is you can chain exploits together as we did right here. We've compromised systems at this point, and an attacker actually would commonly want to maintain some sort of persistent access to your system. We're going to take a look at one way of doing persistence. As with so many other things, there are a number of different ways. This happens to be one way that's actually built into Metasploit. We're going to, again, make use of the Net API vulnerability, and we're going to go after 192.168.86.69, and I'm going to set my L host to be 192.168.86.22. And now all I need to do, again, as we've done before, is just run exploit. Once we have exploited the other system, I'm going to run another module. So I'm going to run the persistence module, and I'm going to ask for help. So we're going to run persistence now, and I'm going to say -U, which is going to automatically start the agent when the user logs on. The interval is going to be 5 seconds. We're going to use port 4000, and then my remote system where Metasploit is going to be listening for the connect back is going to be 192.168.86.22. That is the local system. So we have set this up as an auto run in Windows current version under current user. So this is going to be a registry thing. And now all I need to do is reboot, and then I can exit Meterpreter, and I can use exploit multi-handler. And then I'm going to set my payload to be Windows Meterpreter reverse TCP. And then I'm going to set my L host to be 192.168.86.22. I'm going to set my L port to be 4000, which is what we said we were going to be listening on. Then all I have to do is run exploit. I'm going to log in as the user. Now that I have logged in, I have my Meterpreter session, and now all I need to do is just get my sysinfo, and you can see that we have a persistent connection now to this Windows system because it's going to run every time that user logs in. So that's one way of doing persistence. There are certainly others. This one happens to use some functionality that is built into Metasploit, and it's just there for you to use. We're going to use Metasploit again, but I'm going to use it in a different way. So what I'm going to do is I'm going to start up Armitage. Now, Armitage is a graphical user interface that sits on top of Metasploit. By Metasploit, I actually mean Msfconsole. I'm going to say connect, and I'm going to get this error. I'm going to say that I want it to start up Metasploit's RPC server. That's the remote procedure call server. We're going to try this process of waiting for the RPC server to start up. Once it starts up, Armitage will start up here. First of all, we're just going to do a search here, and I am going to search for the distcc vulnerability. So here are all of the hosts that we know about. So one of them we know is a Windows box, and this one we know is a Linux box. So this is going to be my target. Now what I do is I take this distcc exec out of the left-hand pane, I drag it onto the .68 host there, and it pops up all of the information that is necessary for me to just run the exploit. Now all I have to do is say launch, and you can see that down below, it's actually running MSF exec. And what we have is a console. This says that it has a command shell 1 open. I'm going to right click here, and you can see that we have shell 1, so I can upload files if I want, and I can also interact with it. So here's my shell down here. So I can say uname -a, and sure enough, we are in the Metasploitable system. You'll also notice that the icon has changed. It's red now in the border, and it's got some squiggly lines around it. So that indicates that we have a compromised system. I can right click here. I can get the services from it. I could scan it. I could set a label on the host. And again, I can do these things with the shell that I have. So I could upload, for example. And then I could also use post modules. So some of the post exploitation modules that we were looking at before, I can use those. We're using Msfconsole underneath. We're just getting to it in a different way. You've got all of the modules that are available to you right here in a nice little tree form. And of course, if you want to search, you can search here as well. And then once you've got one, you just drop it onto the host that you are looking for. This assumes that your database is populated with the hosts that you know about. Armitage does all of the work for you in terms of calling the relevant things inside Msfconsole, and it just makes it happen automatically for you. We're back on Windows here, and you can see based on the taskbar at the bottom that we are back on Windows. And we're going to take a look at Metasploit using the web interface that comes with the Community Edition, of course, the other editions as well. The web interface, of course, has a more visual orientation than what we have looked at previously. So, for example, we've got the ability to search modules here. We can look for resource scripts. We can manage any credentials that may be available. You can set up campaigns, look at sessions, do some analysis on hosts and services, vulnerabilities. We can do a lot of different things. Something else that we can do is we can just perform a scan. So previously we had looked at using Nmap to do scans. We can do a scan using the modules that are available within Metasploit. And I had previously set up IP addresses, so all of the IP addresses on my local network. And all I've got to do here is launch scan, or I could do some advanced options here. We could look for UDP, we could look for SNMP community strings. We've got a variety of options there. Something else that we can do is we can import data from Nexpose. The way we do that is we would configure a Nexpose console. I don't have Nexpose configured on this particular system, but if you had Nexpose available to you, whether it was on this local system or whether it was on another system, you would just give it a name and then you would give it the address. So the IP address, 192.168.86. Let's say 3, for example. And then 3780 would be the port number because it's going to use the same port that you would use if you were connecting with your web browser. And then you just provided the username and password that you had configured in order to log into the Nexpose console. Just as if you were connecting through your web browser, you're going to configure the Nexpose console. And then that gives you the ability to just run the scan on Nexpose directly from Metasploit. Of course, the other thing that we could do would be to import from a file. And we could select a file if we had done, say, a Nessus scan, for example. We could import data from that just as we had doing the DB import using the Msfconsole. I've got my project listing right here on the home page for Metasploit. So I've got a couple. This is the one that is just installed by default. Nothing's actually configured in there. If I go to my home, that is where I configured my network range. I've got 11 hosts that were discovered. I've got 48 services. So if I go to the 11 hosts, I've got my list of names and IP addresses and the operating system that it believes happens to be there. I could import data, so I've got a list of vulnerabilities that are available for each of these. And you can see if I click on them, I've got services, and we could go, for example, to .68. We could see a list of a number of services that are available on this particular host. So if I want to actually go about doing some exploits, I can do basically the same thing that we were doing before. So I could look for distcc, I could click there. I could set up my target system so I could either plug in the entire range and just let it look for every system on the network that may be vulnerable to this particular plugin, or I could set my target address to be 68, which is a host that we know is vulnerable. So we've got target settings, we've got payload options, basically all of the same things that we had before. And all of the modules that we had available to us before were available. So rather than doing typing and interacting with the system that way, as we have been doing, you can just click around and do a lot of work by just clicking on things. If you're into graphical user interfaces as opposed to hands-on keyboard, this would work out pretty well for you. If you were to actually break into a system, you would be able to get there through active sessions, and you could even see your closed sessions that were available. One thing that you can do with this, and we'll take a look at doing this the old-fashioned way a little bit later on, you could do social engineering campaigns if you wanted to upgrade to Metasploit Pro. You could do social engineering campaigns where you could test to see whether somebody was actually going to open email, clicking on links, submitting web forms, and that sort of thing. This is a pretty common test in enterprises these days because social engineering is such a common attack vector. We can take a look at all of the information that we had basically in the same way that we were able to with Msfconsole. It's just we're doing it through a web interface. So this is another way to use Metasploit and to be able to make use of the Metasploit framework. We're back to Msfconsole here, and I want to look at some client-side attacks. Client-side attacks is where we basically set up a server inside Metasploit and we get clients to come visit us. We can, for example, go search for Internet Explorer. Internet Explorer is going to give me a number of exploits. I can select one of these, and we're just going to grab, for example, this one right here. So I'm going to copy that, and then I'm going to use this one, and I'm going to say show options, and I'm going to set my serve host to be my local interface here. So 192.168.86.22. My service port is going to be 8080. That's going to be fine for my purposes here. My URI path, I'm going to allow that to be random. I could set that if I wanted to say, just give it a path name. So when it started up, I would be going to my IP address / whatever path I set. In this case, I'm just going to leave it random. And then all I have to do now is say exploit. And what this is going to do is it's going to start up a handler, and it's waiting for me to connect using another system. And so I'm going to copy out my URL here, and then I can bring it over to my other system and then open it up there. There's a challenge with doing this, and this can be really time consuming and difficult to do this because some of these exploits are really just not always guaranteed to work. So, for example, you can see that we tried it, and I was using Internet Explorer on a Windows XP system. In this case, this particular exploit didn't happen to work. You could try this and just keep running exploit after exploit on target systems and see whether you can get anything. What I'm getting on the client side is just waiting for a reply from the website. And what happened is we got an unknown user agent. You're going to get a lot of cases where either the exact string that it's looking for isn't quite right, or there may be some other problem. You may have a problem on the client side where something's being caught. I've done a lot of these types of attacks on client systems, and it can be really tricky getting these client side attacks on browsers to work because browsers can behave differently based on what's going on the operating system. And sometimes it's very particular about the version. I'm going to kill this. You can, however, spend a fair amount of time looking for not only Internet Explorer, but we can also find other browser vulnerabilities. There are several right here where we could be attacking Firefox, just as an example. Browsers can be very vulnerable to attack, and there are a lot of different exploit modules within Metasploit that you can play around with to see if you can compromise your systems that you may have available that run these different browsers. Browser attacks are not the only types of attacks that we can do against clients. I could, for example, look for FTP here, and there's a particular one that I am looking for, although certainly not the only one that's available, but it is one that we can play with a little bit here. I've got a fuzzer module here. what this is going to do is it's going to give me the ability to test an FTP client. I'm going to use that. And then outside of here, I'm going to need an FTP client to play around with. And so I'm going to use one called transmit. Now I can show my options here. And the first thing I need to do is I need to set my serve host. So I'm going to say set SRV host to be 192.168.86.22. And then I can just leave everything else alone because that's all going to be okay. Over here, I'm going to set my client to be 192.168.86.22. And then I'm just going to plug some values in here. I need to start up my exploit over here. So I've got a server started. Let me just drag the client over here so you can see a little bit of what's going on. I've got some responses that are just being sent back to the client. Every time I do something here, I get some random values back. And what I had was a really long directory name, and you can see that my client said bad parameter given to library, so it wasn't able to change into that directory, and it couldn't download that file. I've got the ability to interact with a server that's just sending bad data back to the client. I can do client-side attacks using this right here. This is just one type of client attack that is possible. There are a number of other fuzzers as well. There are some services that just have client modules that you can play around with just to see if you can break some client applications using these Metasploit modules. For example, this right here, which was an FTP client fuzzer. Earlier on, we had talked about doing social engineering, and we can do social engineering using the SEToolkit. SEToolkit, similar to Armitage, sits on top of Metasploit, and it uses Metasploit modules in order to function. So I could do things like social engineering attacks, and let's just say we're going to do a spear phishing attack. I'm going to do a mass email attack, and you can see that what we've got here is just a very menu-driven approach where you select exactly what you want to do, and it will actually create the exploit package and then send it via email. Let's try this one, for example, and we could say Windows Meterpreter reverse TCP, and my IP address for the payload listener is going to be 192.168.86.22, and the port to connect back on, we're going to say is 4444. So we're waiting for the payload generation to complete. So what we're doing is we're building a payload that is going to be injected into a file that we're then going to send off to our target. Once the payload generation is complete, we can go and walk through the remainder of the process of sending the email. You're going to either need a local SMTP server or a local mail server, or what you're going to need is login credentials to Google's mail server so that you can log into Google and have Google send your mail for you. Be very aware that Google does a lot of virus scanning, and so it's better to have an SMTP server locally, and ideally you are not on a cable modem network, because using a cable modem network, they will probably redirect any SMTP attempts trying to go out from your network and try to redirect them to their own SMTP server. So this may not work very well on your local network. But you can do SEToolkit and create phishing attacks so that you are sending email to an unsuspecting user with malicious content or malicious attachments. And using that malicious attachment, if you can get somebody to open it, you should be able to compromise their system and then get a reverse shell. Payload generation sometimes takes a while to complete, but this is a very simple process of just walking through the prompts, and then you can select any number of the different payload types depending on the type of system you are looking to compromise and the type of clients you are working with. We're going to use SEToolkit again, and this time what I want to do is I want to create a website attack vector. I've got the ability to select different attack methods. I could do a Java applet attack method. I could do credential harvester attack method. There are a number of things that I can do here. What I'm going to do is the Java applet attack method, and I'm going to use a site cloner. In this case, I'm not going to say I'm using NAT or port forwarding because I'm just playing around on my local network. If you did have NAT and you were working with that, you would have to figure out where you were going to use your web server IP address. What I'm going to say is 192.168.86.22. My payload handler is not on a different IP address, and I'm going to use the applet that's built into the Social Engineers Toolkit rather than creating my own. The URL that I want to clone here, we will say O'Reilly.com. And so what we're doing actually is we're pulling the HTML down from the remote site. We're just storing it locally. What I can do here now is just say Meterpreter memory injection, and the port listener is going to be, let's say 4455, because it doesn't really matter all that much. We're going to use Windows Meterpreter reverse TCP, and we're going to now load up the Metasploit framework in order to generate the payload and start up our handler so that we can actually listen here. What I'm going to do is I'm going to go to the web directory on my local system here, and I can already see that I've got a jar file that was created. And if I say cat index.html, I've got the java.class that was plugged in at the very bottom. And if I scroll up some more, I should be able to see that this is the O'Reilly website. Just by looking here, you can see O'Reilly Media. What we did was we pulled the HTML down, and then the Social Engineers Toolkit at the very bottom plugged in that malicious Java applet. The only way this is going to get anybody is if I can get somebody to come to my website right here on my local network using my 192.168 address. So I'm not going to be infecting anybody at all here. I would have to get them to come to that page in order to get them to load the applet that is in place there and hopefully exploit them. And then you'll remember we've got the version of the Metasploit framework running with just the payload handler listening for connections back on that IP address. We can use the Social Engineers Toolkit for web attacks pretty easily. We're going to take a look at the browser exploitation framework, otherwise known as BEEF. I've got the BEEF XSS framework right here. I'm going to click on it, and we're going to wait for BEEF services to be started. Once BEEF services are started, we need to hook a browser. And let me just go back here because it says what you can do is you can create a page and plug this into the page. And so in our case, for 127.0.0.1, I'd plug in 192.168.86.22. I could plug that into a web page, and then I could get somebody to go to that web page, and then I would have hooked their browser. I'm going to just log in. Username is beef, and password by default is beef. What I can do is just go to the basic demo page. And at this point, I should be hooked into BEEF. And so what I should be able to do is browse around here. And I can go back to the BEEF control panel. And what I've got is a listing of information about my browser. Now I can go to the logs here and notice what is going on with my browser. You can see that I did some typing, and that's one thing that I've got with Beef is I can grab keystrokes. I've got the browser windows lost focus, appears to have come back online. So I've got a number of events here that have taken place and shows up in the logs. I can start issuing commands to the browser as well. I could detect whether the browser has real player support, for example. I could run that, and it looks like we didn't get anything back from there. So I could remove a hook element. I could unhook the browser, detect whether there's a pop-up blocker in place or not. I've got the ability to start passing commands back to my hooked browser and doing a number of interactions with the browser that I have access to. I can get a lot of data and start interacting with the browser in different and interesting ways to start creating attacks on the client side, which is the browser. This is similar to some of the other attacks that we've talked about before using Msfconsole, for example, or even some of the fuzzing attacks that we were looking at. In this case, we've got an entire browser exploitation framework that we can use to start going after web browsers on the client side. What I'm doing here is just against my local browser. In order to go after remote browsers, what I would have to do would be to set up a page with that JavaScript built into it and then try to lure people to come to that page so that I could hook their browser and start gaining access to it using the Beef framework. Now, there are a number of applications that you use on a regular basis that make use of files. We can make use of Metasploit to target vulnerabilities within those applications. And so all I have to do here is search for file format, and there are a fair number of exploits that are available that take advantage of vulnerabilities in applications. So for example, here's one that uses nuance PDF, and there's apparently an overflow vulnerability there. These are generally pretty easy to take advantage of. And let's just use a really simple one here, for example. Just grabbing one randomly. And I'm just going to copy this. And now I've got it copied. I can just paste it in. Now, if I say show options, what I've got is just the file name. I could set the file name here to something else. So I could say set file name to something. And then all I need to do is say exploit. And what that should be doing is generating the file for me. What we end up with should be a file that we could then send to somebody. What I don't have here is the ability at this point to interact with the system. And so I'm just going to kill this, say set payload to be Windows, Meterpreter, and then reverse TCP. And then I can set my L host to be 192.168.86.22. And I could set my L port to be, let's say, 5555. And now all I have to do is say exploit at this point, and we're going to create a file. And what it's going to do is it's going to give us the ability to, once the system has been exploited, get that reverse shell back from the targeted host. What I need to do once I've done that is I need to set up the reverse handler. And so in that case, what we would do would be to say use exploit multi-handler, and then I would set my payload to be Windows, Meterpreter, reverse TCP, and then I could set my L port to be 5555, and then set my L host to be 192.168.86.22, and then I run exploit here, And now what I've got is a reverse TCP handler that is just waiting for a connection on port 5555. So all I need to do is send important report.docx to somebody, and here's where it is stored. If I send that to somebody, they open it up. If they are vulnerable to the vulnerability that we had targeted here, we may be able to exploit that vulnerability and then gain access to their system. So this is another way that you can target client-side attacks, and you can do it using file format vulnerabilities. And as I said earlier, there are a large number of exploits available in Metasploit that go after these file format vulnerabilities. In the past, we have grabbed password hashes as we've broken into systems, and those hashes don't really do you an awful lot of good as they are. You really need a password cracker. There are some good password crackers that are available. One of them is John. John the Ripper is a password cracker that has a number of capabilities here. We could go in single crack mode. We can specify our input encoding. A really easy way to get started with John, though, is to find a password file, and we can take a look at the password files that we have grabbed here in the past. And what I can do is I can copy this, and then all I have to do is say John, and there we go. We've got 7 password hashes, and it looks like there were 7 different salts that were available. So we've loaded up the password hashes into John, and what it is going to do at this point is it's going to run through those hashes using a variety of password attack types, and it's going to attempt to determine what those passwords are. There are fairly easily guessed passwords within this set of password hashes because it came from Metasploitable. So there are some available ones that are there. And if I were to just hit any key here, you could see which passwords that we were attempting to guess through. You can see the statistics that have been provided. I can kill that. One of the important things about any password cracking program is the word list that it uses. Now, you could certainly do brute force attacks and just iterate through every single potential character in every position, but then you got to be able to figure out how many positions there are in the password, and brute force attacks can take a really long time. One thing that is really time saving is the ability to use word lists, because for the most part, people are going to use some form of words typically when they are selecting passwords. We've got some word lists available here. One that's actually pretty good is RockU. And I can say copy RockU out to my home directory, and then I can just unzip RockU. And once it's done unzipping, we can take a look at RockU and see all of the passwords that are available there. One thing that we get using these hashed format files, so for example, the one that we were looking at before in MSF4 loot, if I were to take a look at this file that we had looked at, what you would see is I don't have to guess the username because it's right there. So I've got root, MSFadmin, Postgres, Klog. I have the username, so all I really need to do is guess the password that's right there. And what we do in order to do that using a word list is we hash in the same way that this file was created, whether it's MD5 or SHA-1. We do a hash and then compare the hash results. And that's how these password crackers that use word lists actually function. And the same thing is true when you are brute forcing. You generate the password, you generate the hash, compare the hash. If you've got a password that generates a hash that is the same, you can say that you've got the password. Even if there is a hash collision, which is unlikely, but it happens, it doesn't really matter whether it exactly matches the original password. The only thing that matters is whether the hash matches. If I can get the hash to match, I can log in using that user and whatever password we came up with that generated the correct hash. So you can use John the Ripper in order to do password cracking. It's really good, functional, it's free and open source, and it's a good password cracker that you can make use of. We're going to take a look at another type of password cracker. I talked earlier about using John the Ripper and mentioned the idea of doing brute force passwords. Now, what I'm looking at here is a program called OPH Crack, and this uses something called rainbow tables. Rainbow tables are tables of already computed hashes. So we've got pre-computed hashes. A good rainbow table can be really, really large because it will have taken a very large number of potential passwords and generated hashes for them. The advantage to this is all I've got to do then is do a lookup on the hash that I've got. If I've got the hash, I don't need to actually go through and compute all of the hashes because that's already been done for me. So I'm going to look up the hash and then I am going to just be done at that point. So I've got a password hash here, and I'm just going to delete everything that comes before this, and I'm just going to do a single entry. So this is something that I grabbed using run hash dump out of Metasploit. I did the hash dump. I've got the dump of the hashes, and you can see that this is the format that is allowed. So I could also just specify the hash, and that would also work. I've got the hash, I've got the NT hash, and now what I can do is I can just run a crack on it. And if I've got a good set of rainbow tables, this should actually be pretty quick. If I had a really good set of rainbow tables, that could be really large. We're talking potentially multiple terabytes of a really good rainbow table. This is another way of doing password cracking, though. This saves you the computation time of generating the hash every time you want to check another password because the rainbow table has already done that for you. And the only thing you're doing with a rainbow table is a lookup. The idea here is all of the computation's been done ahead of time. And so password lookups should be really fast in that case. Now, we've talked about doing password cracking if you've got a list of passwords. What we're going to do now is go about password cracking in a slightly different way. It's not password cracking in the sense of you've got a hash and you're trying to guess the password from the hash. In this sense, what we're going to be doing is just blasting a lot of passwords at a service. So we're going to use Hydra for this. I'm going to say Hydra -L, and we're going to use MSFadmin as the username. I happen to know that's the username that works. We're going to use a password file, so we're going to say uppercase P. We're going to use rocku.txt as our password file. Now here, what we're going to do is we're going to specify the service that we are going to try to get in with. And you can see the supported services listed right here. In our case, we're going to try to use SSH, and we're going to target 192.168.86.68. If there were a port that were used that was different than the standard, in this case, the standard is 22, then you would specify the port in this way. So let's say somebody was using 2222 as their SSH port. You could say 2222 here is going to be the port. Now, the reason this is called Hydra, by the way, is it goes back to mythology. Hydra was a multi-headed beast. This is multi-headed in the sense that it can spawn multiple threads at the same time. We are going to try to attack this server using 16 tasks at a time. And apparently there are that many login tries because that's the number of passwords that are in the password file. Now, if we didn't know the username, we could specify uppercase L and provide a different file with the usernames in it. So there may be a different file with usernames as compared to the passwords. Not surprisingly, you're probably going to use different words or characters in your password rather than your username. Hydra is one way of doing brute force attacks on services in order to try to get into them. Now, one of the challenges with doing this is that it's very noisy because this is going really fast. And you can see here, for example, it says almost 4,300 tries per minute. That's a lot of attempts going, and it's going to generate a lot of traffic to the host that you are going after, which could end up with alerts and so forth. So be very careful about using tools like Hydra if you're trying to brute force the password. Ideally, you'll get it done really quickly and get in before alerts start going off all over the place at the target. You can use a tool like Hydra to do some password cracking, and there are other tools that will do that. We'll take a look at another tool that will get you in doing the same sort of thing, and we'll do that coming up. Another tool that you can use to really brute force remote logins is Patator. Patator, just like Hydra, has a number of capabilities in terms of protocols. So we're going to run Patator help, and you can see the protocols that are supported by Patator here. You can see the available modules: FTP login, SSH login, Telnet login, SMTP login, and so forth. So there are a number of protocols that are available. We're going to use Patator to do an FTP login attempt. And we're going to say FTP underscore login. Host is going to be 192.168.86.68. And then we're going to say user equals MSF admin, password equals file 0. And now we've got to tell it what the file name is. And so we're going to say rocku.txt. We're going to exclude anything that is an ignore, reset, retry. And for that, we're going to say code equals 500. And we're going to say also exclude reset where code equals 230. And then we're also going to exclude anything where the message equals login incorrect. So you can exclude things from the output, and that makes it a little bit cleaner here. We're going to run that, and what we're going to see now is the output where there have been attempts. In this case, we're getting all of them because I must have not excluded something about the login incorrect correctly. So we are getting all of the attempts here. But you can see that with Patator, you can use password lists, you can use user lists, just like you can with Hydra. With this, you can also do things like excluding particular information and determining exactly what it is that you want to see. Patator is another brute force program. That is another way that you can get in using some of these protocols. Sometimes you'll find that Hydra is a little bit better. Sometimes you'll find that Patator is a little bit better. But frankly, you could use either of them in order to do your brute force attempts using just regular user lists or password lists. And you can use multiple protocols using either Hydra or Patator. I want to take a moment and just say thank you for using these videos. I hope they've been helpful to you. I know we've covered an awful lot of ground. We have used tools like Dig and Nslookup in order to acquire information from DNS servers. We have also used tools like Nmap in order to identify open ports. Nmap is a really useful tool, whether you're doing SYN scanning or whether you're doing fin scanning or UDP scanning or whatever you want to do. Nmap is a very versatile program. We also, of course, spent a lot of time using Msfconsole in order to do scanning and identify hosts that we had some information about, whether from a scan or from something that we had imported. We've also used exploits and been able to search for those exploits using Msfconsole. And we also looked at vulnerability scanners like OpenVAS, for example, and Nexpose and Nessus. And we also spent some time using Hydra and spent some time using Patator and other password cracking utilities like John, for example. We have spent a lot of time using a lot of tools. And as I've mentioned before, it's really helpful to get yourself a few virtual machines where you've got, say, Kali Linux or a Windows system, if that's what you prefer. And you've also got Metasploitable, whether it's version 2 or version 3, whichever you want to play with. And ideally, you've got some Windows systems that you can use as targets as well. Using all of these tools, you have to keep working at it in order to get better and really understand how they behave and be able to recover in times where they're not behaving quite the way that you think. So again, thank you very much. My name is Rick Messier, and I've been doing penetration testing for several years. I've been involved in information security for decades now. I really hope that you enjoyed the time that we've spent working through these various penetration testing tools.